No, you are the most important, without which we won't have PyCon. Yeah. Yes. So Dr. Liew is oh, I didn't put is the
Oh, I don't worry. Don't worry about it.
BDFL. Yes. PyCon SG APAC. Yes. So what is BDFL? Yeah. So BDFL is the term that people give to this Mr. Gildo, the creator of Python, meaning benevolent dictator for life. Yeah. Yeah. So as someone who started PyCon Singapore and PyCon APAC, which year was it? 20 something?
The first conference I think was 2010, where I think we started doing some groundwork 2009.
Okay. Okay.
So that's about 11 years or so, 11, 12 years.
Yes. Okay, cool. Then Education Summit was started in 2015. Yeah. So we borrowed
2015.
Yeah, that's right. We borrowed the US model.
Okay.
And tried to have a separate gathering for enthusiastic educators.
Yeah.
Yeah. So over the years we have quite a steady turnout. Right. Yeah. So this year is about 30 plus. Yeah.
Yeah.
I mean 30 plus sign up. Yeah.
Mr. Gee, were you at the first PyCon APAC in 2010?
I was at one of the PyCon APAC. I can't remember which one, whether it was the first one. It was at Republic Body, I remember. Yeah.
Okay, that was not the first. The first one we had it at SMU, and okay. Actually we had a education track in the first PyCon APAC.
Cool.
Yeah, but I think after that we didn't quite continue with that track.
Yeah.
I see quite a number of familiar faces. Prof Leong is here. Oka, Norman, regular contributors.
Yeah.
Thanks, guys.
We won't have such an event. Yeah. Thanks for supporting all these years. Yeah. Okay, so later there will be a short segment where everyone will introduce yourself. Yeah, so please don't be shy. Yeah.
Myself. Okay. Yeah. How many people have signed up this afternoon?
From my list, it was about 30,
okay.
30, 30s. Yeah.
Okay. Good.
Okay, so it's 1:55. Yeah, so we can get started with the opening. Miss Dr. Liew, if you want to have anything to share, you can share your screen. If not, you can just talk. Yeah.
I got nothing to share on my screen. I only got 5 minutes, and like I said, I just have a few words. Well, I'm going to start by saying that everyone tends to say only at the end, which is to wish everyone an enjoyable conference, right? That's what most people say at the end. But what makes an enjoyable conference? You think about it. I thought about it, and to me, it's like people, right? Just people. So I'm thankful for folks like Mr. Gee and others who work at putting up the PyCon SG Education Summit, and the fact that a lot of these works are all done on a voluntary basis, right? So without people like him and their perseverance, right? After when he said he started it in 2015, after what, 6 years? Without people like him and his perseverance, these kind of meetups don't happen naturally, right? And I think we will be all the poorer for it. So Mr. Gay, big thanks to you. I'm thankful for the speakers this afternoon, right? Again, people, right? So like platforms like this only work if there are people that are prepared to step up and share their new learnings or their new experiences or their best practices with using Python, and in today's case, in an educational context. I mean, within this setting as PyCon SG, it wouldn't be amiss of me to say that, I think the beauty of Python as a language lies in its ability of platform or a language that allows a lot of computational experiment. For us educators that can across many different domains, subject areas, your need, right? So that's another group of people that I want to thank and acknowledge, right? Because that's what makes meetups or summit like this. Finally, participants, right? You are all people as well, right? So if you're new today, I mean this is your first PyCon SG Education Summit. Well, I hope I welcome you and hope you enjoy this. But do look to extend your participation beyond just checking things out. I hope it goes beyond that. Yeah, you make new friends, build new networks, and tell others as well. Right, you do have a voice. And talking about voice at a wider level, I think there are a lot of things happening, can happen within SG, is happening within SG, and even outside, right? So SG folks, I think, can and should be contributing to more Python community projects and not just as users. I think that's something that I am hoping to see more happening. I mean, you see that in a lot of other communities in the Asia Pacific region, in Japan and so on. They are maintainers of Python projects and so on. So I think we want to see that happening as well with SG involvement. And summit talks at Python conferences worldwide, right? Especially the one at PyCon APAC, which is happening in Bangkok, Thailand this November. So, I speak that on myself as well about seeing whether I can submit a talk there. So, in short, well, this summit is what people make it out to be. Those of us that are here and maybe those who are maybe not here yet, but this summit is really what people make it out to be. So, so for the rest of the afternoon that you have, I just wish you all an enjoyable conference. And with that, I just pass the time to Mr. Gee. Thank you very much, Mr. Gee.
Hi, yeah, thanks very much, Dr. Liew. Yeah, unfortunately, Dr. Liew has quite some commitment this afternoon, right? So otherwise, he actually wanted to share one of his projects, right, which will be quite interesting. So we will reserve it for another session. Yeah. So that's yeah. Okay, sure. So okay. Yeah, thanks very much. Yeah. So this is roughly the agenda for today. After the welcome, we will now have Miss Jovita Tang from School of Science and Technology, Singapore, to share with us this open source tool using Orange in the teaching of AI. Yeah. So I will stop presenting and hand it over to Miss Tang.
Okay, hello. Thank you very much for the introduction and yeah, for inviting me to share what I have done with my students as well. Let me present my screen. I think I need to give a disclaimer first, lah. Okay, this is PyCon, but then the first talk is not exactly Python based. In the sense that I'm talking about using Orange for the teaching of AI. And although Orange is coded in Python, there is very little coding required in the use of this tool. Yeah, and I think that's the beauty of it, especially when it comes to introducing students to AI and to ML. Yeah. Can everyone can see my screen, right? And everyone can hear me also.
Yes.
Yeah, the standard checks. Yes, very good. Okay, so let's jump right into this. So I'm talking about this software called Orange. Okay, yes, it's spelled like the fruit orange. And it markets itself as a data mining software, but as we'll see later, there are quite a few tools that are available for performing supervised and unsupervised machine learning as well. Okay. So yeah, as Mr. Gee has said, my name is Jovita. I'm from the School of Science and Technology. So just want to share a bit about myself first. Okay, this is my third year in teaching in SST, also the third year teaching computing, because I only started teaching computing when I joined SST. And also subsequently, this is also my third PyCon lah. Yeah. Okay. So my first experience with ML or with AI was actually in 2010 when I learned about natural language processing. Okay, so just want to shout out to the linguistics department at NTU lah, okay, for giving me that, for opening my eyes. Okay, it was love and at first sight for me, and I never really looked back. Okay, so much so that when I wanted to do a master's in 2015, I decided it has to be something in a related field. Yeah, so yeah, so that's a bit about me, and I think this background later on you can see like this is also how it has shaped me to want to introduce AI to students, and how I decided to do it as well. Yeah. So for those who have no idea what on earth are these terms I'm throwing about, right? AI and ML, all these things. So I'll just do a quick introduction or quick definition of these things first. So I think AI should be quite familiar to all of us. Okay, even if you're not, even if you're new in the computing science field, I'm sure many of us have watched or read science fiction stories before. So if you have that layman's thinking that artificial intelligence is about robots that can mimic humans' way of thinking, then you're not far from the truth, actually. Yeah. So AI has been around for a long time, but with the immense amount of data collection and storage that is made available through the invention of smart devices and the connectivity through the internet, the currently favored approach to AI is using machine learning. Okay, so last time AI was done a lot through a rule-based kind of approach, but now we just let the computer learn everything by giving it a bunch of data and letting it learn on its own. Yeah. So with machine learning, what happens is actually we just feed the computer a lot of data, and then the computer will learn the subconscious patterns about human behavior and allow it to replicate that human behavior, sometimes even better than any conscious rule-based system ever can. Yeah, and ML is currently being favored because, first of all, because it usually it performs better in many cases than rule-based AI algorithms, and also it's also less tedious to code. It's faster to program as well. Yeah. So just want to illustrate what I mean with this traditional AI approach and ML. Okay. Here's a rough flowchart. Okay, for traditional AI programming. So we always start with a problem. Okay, we want to study that problem, and then we decide to write a bunch of rules to describe the problem, describe how you should solve it, and then you feed these rules to the computer, and then the computer should learn how to solve the problem. And of course, if it doesn't solve the problem well enough, you have to analyze what went wrong, and then you write more rules, and then you give it to the computer, and then hopefully the computer learns to do it better. So it's very tedious, right? A lot of you have to really go down to the nitty-gritty and think what kind of rules are needed in order to make your computer mimic human behavior, right? So I think an example of this is teaching a robot to play chess, right? So for example, chess strategies have been studied for years, so we can code all of them out, and by doing so teach a computer to play chess and even to beat the grandmasters of chess, which is what they did in the very early chess robots lah. Okay. Yeah, but that will take a lot of time. And if you miss one strategy, your AI system might be flawed, right? So that is why currently ML is being favored. So with ML, all you need to do is actually let the computer watch. Okay, I say in quotation marks, okay, watch thousands or millions of chess matches, and then it can actually pick out all these strategies on its own. In other words, the machine will learn from the data you feed it. Okay, hence the term machine learning. It learns from what you show it. Yeah. So this is a typical machine learning process. This is supervised learning, I would say. Yeah. So when you want to do machine learning, it starts with gathering data about human behavior. Okay. Then you tidy it up, you do some pre-processing, and then you teach the data to the to a computer. Okay, sometimes we want to try different models of learning or tweak certain parameters of the models so that the computer can mimic human behavior better. Okay, but in general, it is still much easier to do than writing down a long list of maybe 10,000 rules, right? So finally, when we're trained the computer when we're trained the computer with the data, we can use this model to make predictions or to play chess or do whatever we want to mimic that human behavior. So that is basically, in a nutshell, that is what machine learning is all about. Okay. I think in current lingo, AI and ML are used interchangeably, okay, because ML is working so well as artificial intelligence approach that many people have forgotten what it was like in the days where we did rule-based AI. Yeah. So so that's basically the background of what I want to teach to my students. Okay, so you can see why it's exciting stuff lah. Okay, the problem with with AI, you can see that machine learning is the future. So we want to prepare our students for it. Okay, but that's where I hit the snag because some teaching or programming machine learning is not easy, right? It needs a lot of your students need to be very familiar with Python. Okay, and that's the problem. Okay, when I was here in SST, although yes, we're SST, we're supposed to be a bit, in a sense, maybe our students are geekier than those in other schools. Okay, but then our students still are at varying levels of Python programming. Some have been doing it for many years, but some have only just started. Yeah. Okay. So yeah, in many instances, I have many students who are like in the picture on the right, right? Okay, you take 253 attempts before their code can compile. Okay, and then they feel very happy about it. Okay, if they feel happy and optimistic about it, that's still good. Okay, some of them they feel very dejected and they want to give up after the 10th attempt, right? That's very common among all of us. I think secondary school and JC educators in Singapore. Okay, maybe even this experience maybe even sound familiar to the university lecturers here, right? Yeah, so so that's the problem that we face now. Okay, because our students are at varying levels of Python, I don't want to jump straight into scikit-learn and TensorFlow. These are Python packages that are that are very commonly used to do machine learning in Python. And these are the tools that the experts will also use. But to jump straight into it, the students who are already lost with basic Python programming will get even more lost, right? So it will overwhelm these students to just jump straight into using Python to teach ML. Okay, but at the same time, right, I also have students. Our students are very geeky, right? So many of them already know the basics. So the basics of, look, you give the computer a bunch of data and the computer will automatically learn, right? They already know their basics. So if you use the sites like Teachable Machine or use some of the activities in this machine learning for kids website, they are too basic because they treat the ML algorithms like a black box. You feed it data and out comes a prediction. My kids already know that, so there's nothing new in using these things. So so where do I go from there, right? So to move forward, I thought back to what I did in my master's. Okay, so when I was doing my master's, my course used this software called Weka, okay, to let us play around with the machine learning models. Okay, so it was great because it's code free, okay, and it's also money free, which is what all of us educators love, right? Especially yeah, not paid enough, hashtag not paid enough. Yeah. Okay, so yeah, so yeah, I mean, when we use, I was thinking maybe I can use something similar to Weka, okay, because Weka is code free. My students do not need to struggle with the Python in order to learn the machine learning if I use a tool like Weka. Okay, and there are tutorials online as well, that teach that can guide the students along, okay, in using Weka. Okay, but this is what the program looks like. Okay, so this is what Weka looks like. If you look at it, there's a lot of words, right? A lot of text. It's very dry. Okay, so the classifier you see in this picture here is actually a decision tree, but when you look at the screenshot, you never know that lah. Okay, because it's so there's so many text. There's no tree structure, right? So while Weka had its plus points, it was not quite student friendly, in my opinion. And I also, when I recall my experience in my masters, I also remember something similar. Like, okay, I was just going through the motion using the tool without really knowing what I was doing. Okay, there was no big idea, big picture about the whole machine learning process. Yeah. So so these were the negative points about using Weka. Okay, it was unintuitive, too dry, too unexciting. So this is where I started exploring Orange. So I think Orange is not new to PyCon. I think in the 2019 PyCon, someone did share about Orange. So that is when I think so. I guess that's something that kind of triggered me to think about it and learn to find out more about it. So what I found out was that Orange, as the tagline here says, is actually it is fruitful and fun. Yeah. Okay. So although it brands itself as a machine learning software, it has a lot of available tools for machine learning. And even better, okay, because as you can see in the picture here, the flow lines, with the flow lines, you can actually see at a glance the story of what's happening to your data. Where does it start? Where does it go to next? What happens to it next? And then you can see that whole machine learning process. Yeah. So here are some of the tools available for use. Okay, Orange likes to call them widgets. So these widgets are organized in drawers, so you can easily find what you want. And if you want to do some specialized, something more specialized like text analysis or even studying gene sequences, Orange has some add-ons that may be just the thing you need. Okay. And yeah, so and when you use Orange, you don't even have to type any code. You just drag and drop the widget into the canvas and then double click it to see the available settings and tweak whatever you need to do. So my students were able to get the hang of it pretty fast when I introduced the tool to them, because I mean, to them, they are digital natives, right? Clicking, dragging, dropping is very intuitive for them. Yeah, and there's no code needed. No need to learn to write any code. They just need to know what are the settings that are required for them to tweak in order to make the model work. Yeah. So yeah, so Orange also comes with pre-downloaded or preloaded ML data sets. So they also actually, some of these data sets that are available in Orange already are some of the popular ML data sets. So just like for example, the Iris data set or the Titanic survival data set, so that you and your students can have your first foray into ML using tried and trusted data. Okay, and besides playing around with these data sets, it's kind of like an ML milestone as well, right? So on the other hand, if you already have a data set that you want to work with, you can also upload it as a CSV file or Excel file. Yeah. So got questions. Okay, I'll talk about that later. Actually, I have no experience with Azure. Yeah. But maybe I'll hazard a guess later. Yeah, maybe just share with you a bit more about what Orange can do first. So if you remember, there were roughly 5 steps to the machine learning process in Orange. And with the color coding of the widgets in orange, you can roughly know where to find the widgets that you need to fulfill each step of the process. Yeah. So even this color coding is also useful for students that I found. So when I tell the students, okay, I want them to explore the data or explore a few more models, okay, by linking up to the data and look at the predictions, I can tell them, okay, look for the blue widgets. The blue widgets are the ones are the models. So link a few more of the blue widgets and see whether you can get a better prediction. Yeah, so they understand me immediately. Yeah. So that is what Orange is capable of. Okay, and now I just want to share a bit more about how I use Orange in the classroom as well. Okay, so for those teaching in MOE schools, yeah, this learning design map might be quite familiar to you. So this is a typical flow of my Orange practical lessons. I usually start with giving students a self-directed slides with clear instructions and screenshots, so because it frees me up to walk around the class and help students who do not understand what's going on or who got stuck along the way. So the self-directed slides are fairly easy for students to follow from experience. So along this way in the slides, I also do ask some questions about the visualizations they create or the predictions that they make. Okay, so this allows them to think deeper about what they're doing rather than just following step-by-step instructions. And they're also encouraged to talk to their friends if they get stuck or if they don't really understand what they're seeing. Yeah. So towards the end of the lesson, I will select some students to share their answers, and then we'll have a short discussion in class. Sometimes I'll even teach a bit more about how the evaluation of the models works. So now they've done some modeling, how to choose the best model. Yeah, that's the evaluation phase. Yeah. Yep. So if you want to know what my self-directed packages look like, okay, here are some screenshots. So I have step-by-step guides. I have a screenshot here. I tell them first click this one, then make sure your settings are set along similar to mine. Okay, so that is the scaffolding part lah. Especially at the start when they do not know what to do, it's good to give them the specific instructions of what settings to use. Then later on, they can start to play with the settings, maybe tweak it a little bit, see what changes. Yeah. Especially at the start, my first few tutorials, I also use GIFs in order to show them where to click and where to find the settings. Yeah. So when it comes to the getting students to ponder and think a bit deeper, so here's a sample question that I get them to think about. Okay, so based on your exploration with the visualizations, they identified some features that would be very defining when it comes to predicting. And you notice here I'm talking about Pokemon because I use a Pokemon data set. I felt that using a data set that is a bit more interesting, a bit more relatable to them might get them to be a bit more interested in the topic. Yeah. I don't know if I have a link to where I get the data sets from. I always go to kaggle.com for my data sets. Yeah. Yeah, so then the students will type their answers at the bottom. Yeah, sometimes I'll get them to take screenshots of what they have as well, so that they can so at least they know when they look back on their tutorial, they can recall what they did in class. Yeah. Yeah. So because AI ethics is important as well, I thought I'd just put this in as well. So I conducted a modified version of MIT's lesson on algorithmic bias. The original lesson actually uses teachable machine to teach AI to identify cat and dog pictures. So instead, I use Orange. Orange as a image analytics add-on, and it was pretty seamless lah, and surprisingly easy to use as well. If you think image analytics, computer vision is actually quite a difficult topic, right? But Orange was able to do it quite seamlessly for me. Yeah. Yeah, so here's some of my customer feedback from my students. Okay, this is just to end off to end off the sharing. Yeah, so here you can see that about over 70% of my students find the exercises in orange helpful to in their learning of ML concepts. So I have about 42% agree, 31% strongly agree. So that justifies the need for hands-on practical sessions, and justifies the need for easy to use tools such as Orange. Yeah. So I extracted some of the open-ended feedback that they've given that is relevant to Orange. So I think my students do love the hands-on activities, and the Orange added to their experience and deepened their knowledge in machine learning. On the flip side, what they want to see improved is more use of Python actually. So I think what they're trying to tell me here is that while Orange is great, it cannot replace teaching of ML using Python modules. Yeah, so Orange can be a good introduction, but for some of the more advanced students who are already very comfortable with Python and they're ready to move on to the next stage, I think Orange can only be introduction. The students will still want to go deeper, and we should teach them to go deeper as well, using using the Python modules. Okay, so I think when I started the talk, I did mention that Orange is coded in Python, and Orange actually does have a Python module, so you can do some coding using the Orange module, Orange package as well. But I think when it comes to doing ML in Python, the gold standard, the tried and tested packages are still scikit-learn as well as TensorFlow. So I think even for myself if I were to run this whole package again, ML package again, I would deepen. I would go further into the Python using scikit-learn and TensorFlow, simply because there are many more tutorials online, and there are many more Stack Overflow solutions online as well that students can refer to help them if they get stuck. Yeah. Yep. So to summarize it off, I did a short comparison between Orange and Weka. So yeah, I mean Weka has its users and a lot of universities still use it, but I really do want to advocate for the use of Orange, especially for people who are not very familiar with coding, and especially for, I think, the age group that I'm targeting, which is a secondary school age group. Orange is more colorful, more visually appealing, and more engaging, I would say. Yeah. So thank you so much for your time. I'd like to hear if you have any questions. Okay, let me take a look at. Yeah, please do share.
There are some questions in the chat.
Yep. I'm trying to open up the chat. That's not really open for me. Let me see. I don't know why when I click the chat, it doesn't.
Okay, so the question
Yeah.
is from Shen Ong.
Mm-hmm.
Yeah. So first question is this an introductory module? How long does it run?
Yeah, the chat is really not the chat box is not really opening for me. So you're asking about introductory module. You mean?
Is this
Yeah,
for
sorry.
which level of students, and is it the first lesson to AI?
Okay. Yeah, so I do teach a bit of the theory first. So my package for AI when I ran it last year was about 5 weeks long. I split it up into I have 2 lessons a week lah. Each lesson is about 1.5 hours long. So I split it up into one lesson on theory, 1 lesson on practical. But even when they're doing the practical, right, the theory is mostly on the theory is mostly focusing on the models itself. So when they try out the models in Orange, I usually do a consolidation by talking about how they can evaluate the models. So even when it's so-called a practical lesson, I do talk a bit about theory also lah. Yeah. So if this whole package is meant to be an introductory package. So I start off with the theory, of course, because to set the context and background for the students. And yeah, and
Yes, sorry,
yeah,
Jovita.
sorry, yeah,
Yeah, just I might have missed it. You said 5 weeks, is it?
yeah,
And
yeah,
two lessons, so it's about
two
10
lessons.
lessons.
About 10
Okay.
lessons, 3 hours per week, so that's about 15 hours.
Oh, okay,
I don't
okay.
go, I guess I don't go very deep
Yeah.
into ML. There are a lot of things in a sense I had to simplify lah, because I think what is more interesting for the students at this age, they are 15-year-olds by the way.
Mhm.
It's more to see how how the models can make predictions, how to see the magic happening lah. Yeah, so I
Mhm.
didn't really go deep into things like the evaluation or even like cross validation or these things. Yeah.
Okay.
Yeah.
Okay. So
I
but if you if they are if their learning objective is also to know like how the different models are working, right?
Mhm.
So there has to be some element of evaluation, right? Um,
Ah.
so um, is there any way that you actually teach the evaluation one? You know, I mean,
Mhm.
they should know the difference between a regression and a classification. You know, right?
Yes.
So
Yeah.
like,
Mhm.
how I'm asking like, how do you teach that? So that
Mm.
actually that's not in my question. While you mentioned it,
Yeah.
I went,
Yeah.
that's a good question. I didn't
Yeah.
think of that.
Yeah.
So that's
Good
one.
point. Good point.
And
Yes.
and the
Mhm.
second, so my main question, this one that I really want to know, do you ever touch on hyperparameters? If you do, how do you
Mm.
do that? Because I think tweaking the hyperparameter is I'm actually teaching the AI for SG
Oh,
in the
nice.
Polytechnic,
Oh, cool.
and it's tough to
Yes.
teach the hyperparameter part is tough. So
Uh,
students actually within one setting, students actually ask about it, and
uh-huh.
when they ask about hyperparameters, like why this number, why when you change this number, it will
Uh-huh.
change already. It gets better. The root mean square error gets better, and then
Ah.
like go into the maths meh? That's the question. So have you tried it before? Just asking.
Yeah,
Thank
okay.
you.
Maybe I'll talk about the first one first. Yes, definitely students need to understand the difference between regression and classification. That is a very basic fundamental of supervised machine learning, right? So we do teach that in the theory. Uh, if you're talking about event what we call in MOE we call assessment of learning, right? Or assessment for learning. We did uh test them a little bit about the theory in our end of year exam as well lah. So I did specifically ask them about whether they can identify a regression or a classification problem. So what we asked them in the exam was I gave them a few scenarios. Can they tell me which is a classification problem, which is a regression problem? Yeah, so they are able to identify largely what is regression and classification. And I think yes, that is also strengthened when they do the practical, because they realize that how come some models, when I try to link it to my data, right, it doesn't work, and some models can work. So because some models are specifically for regression, right? Linear regression is definitely a regression model, right? And there's some that can be used for both, like the tree diagrams can be used for both. So that's where they learn that there are certain models that are specifically used only for regression, some that are only specifically used for classification, and some for both. Yeah. And I do talk about a little bit about these certain, the so-called popular, I call them the popular models that are used for regression, and those that are popular for classification as well during the theory phase. Yeah. But of course, I mean, in theory, with 1.5 weeks of theory, 1.5 hours of theory per week, there's not a lot, right? So that's where Orange comes in, that they can drag and drop a few more models on their own and see what works, what doesn't work, what can fit my data, what cannot fit. Yeah. And that's where they can start to think, how come this one cannot work? Then sometimes they'll ask it in class. Then that's where they learn that, oh yeah, there's some models that can only be used for certain problems. Yeah. So that is how Orange can support that. As for your second question about the hyperparameters, I because I do teach when I introduce it to my students, my 15-year-old students, I do it in a very, I think, more simplified way. So although I do mention the term hyperparameters, I do talk to them a bit about what hyperparameters are, but we don't really do a lot of tweaking of the hyperparameters in the use of orange. But I think nevertheless there are ways to use it. Let me just see if I can share or pull out my orange really quickly. Let's look at this one. Yeah, let's look at this one here.
Okay, sorry, we'll keep this as the last question.
Yeah.
The
So sorry. Yeah, I think I'm overrunning very badly, right? Yeah.
There's one speaker who needs to go and pick up his kids.
Okay. Yeah, so sorry about that. Perhaps we'll take it offline, Shang.
Yeah.
It's a great
Thank you,
question.
Jovita.
Yeah.
Thanks. Or you can use the chat. Later on, we'll try to share the email addresses of everyone.
Sure.
Yeah, thanks.
Yeah.
Okay, thank you very much. Boss Tang. So we really need more role models, competent teachers like Boss Tang, female and enthusiastic. Right. So hopefully more can come into our system. Right. So we will move on to the next talk, and it'll be from Mr. Tan, from Liew High School. Right. So he'll be sharing on using Blender in the teaching of programming concepts. Right. Blender is a open source 3D modeling tool. Yeah. So Boss Tan, when you're ready, please take over.
Okay, I can take over from here. Okay, I'm Mr. Chan here. Okay, let me share my slide. Share my entire screen. Okay, can you all hear me and can you see my slide?
Yes, very good.
Okay, I'm the one who need to fetch my son, so sorry about that. Okay, so good morning, good afternoon. This is Him Not. Okay, I'm from Liew High School, teaching history computing. So today I'll just share with you how I use Blender in my teaching, particularly on creating exercises for the student. So the demo that I'm going to show you today, right, all the exercise are actually more of a revision for them when I create this. Okay, so first of all, let's maybe tell you about what is Blender. Okay, so it is actually a free open source 3D creation software, and people can use it to create 3D models and animation that you can see in the diagram on top. Okay, so this is not done by scripting, done by student using this software to build some models. Okay. So Blender can do a lot of things. There are a lot of online tutorials to teach how to do that. But for this sharing, I will only focus on this part called the scripting. But because this is the only part, we can use Python to write our script and run the program, and so that instead of doing manually, creating all these processes you can see over here, all the models, you can use script to create them. Okay, so we will be only using this tab. All right. Okay. All right. So why do I choose Blender scripting? Python scripting in Blender. Okay. So basically, what I want to do for me, for my student, I just want them to learn something new, and hopefully, after doing this exercise, they might be interested to do some animation, do some modeling. Okay. I think it's good to pick up some skills. So when I do that, I also learn a little bit on how to model animation, as you can see over here. Okay, so another reason for this is that all the while before I most of the time all the exercise I give my student Python file, then run it idle, then print out, they debug. They're always using this this shell lah, so text based lah. So I bring Blender in so that it'll be a bit different lah. Then when they do the solution, when the solution is done, right, it will be seen in a 3D colorful environment lah. So it looks nicer, and of course lah, if you use the shell, it will only be a 2-dimension, but in Blender you can actually make it in 3D. So you can see where the mistake is, and this is definitely cannot be done in the shell lah, by printing out what you see over here, the shell over here. Okay, then I can with some ideas lah. Okay, so depending on how you create the tutorial and the exercise for them. So for me, I use it to teach certain topics like 2D, 3D arrays. Well, in a lot of cubes, so it can be represented by array, and I can also do 3D way lah. Okay, so something like this. Then they can recursion by coloring this tube and things like this. Okay, maybe they can also change the location if they know how to do that. Okay, so I'll just quickly go through how to do this, and it's not so difficult. So the first step is you can download the program, the Blender program. So just go to Google and type Blender lah. Okay, probably the first thing will be the website lah. Okay, so you go to download, and I always recommend the student to just take the portable version. Okay, the portable version, it comes in the zip file. So once you unzip it and you find the executable, and you can run immediately. So there's no need for installation. Okay, the reason for this is that every year they will make a new patch. So just delete the folder and re-download the portable. You'll always be up to date. Your software will always be up to date. Okay, so this is number 2. Okay, the third step, it has a lot of steps. So actually I created a YouTube video and put all the small steps in it. It takes about 1 minute and 30 seconds. So so in case you miss any step during if I demo, you might miss out step. So I put it over there. Then the example I use here is an animation script. So all the resources that you see in this video is inside the YouTube description below. I put all the stuff in the GitHub link is there. So if you're interested, you can take a look. Okay, so if it's relevant, it might not be relevant. Okay, so I'll just play the video once. There's no sound one. I try to explain as it go. Okay, but I won't go into detail on each of the steps. Okay, because the YouTube is there. So to follow through, the student can actually look at it and look at it once. And some of the UI are actually quite obvious. So it's not so difficult to use. Because I'll play it once and I'll explain at the same time. Okay, so this is I put in steps so that I can see how it goes. So I go to the scripting workspace, open a Python file. Okay, browse to the folder, and then you can a script in Python. So you can open it up. Okay, so after that, I can edit the code in this area. Okay, so I just pretend I edit some of the code and then I can use text to save my code. And then I can also activate the console. Okay, so you need still debugging printout. They still need it, so there's a console where they can do debugging by using printouts. Then they can run the script. After they run the script, then all the printouts will be at the console here. And then the final product will actually be shown in the left top corner. So this is one of the examples I use lah. So they need to orientate the viewpoint a bit, and then this animation script, so they can press the space bar and then the animation will run. Okay, so this is just to, okay, so just like that. Okay, so that's just to show you how to do this lah. Okay, and not so difficult. Just you don't have to install, and if you have the file, you just to run it, and everything is there lah. You can as you can see like the whole process take about a minute. That's all. Okay, but of course, the more important part is how do I make use of this in my lesson lah. So for this exercise, all the resources are in the YouTube link lah. Okay, so I'll just go through with you what's inside lah. Okay, so to help the students, because they may not know what is Blender, they may not know how to create all these 3D models. So to help them, right, I actually create some of the helper functions for them. So they just to call, they don't have to understand what I did over there. So for example, I provided them with a function called create 2D square. They can change the variable, the parameters height, let's say 9. So my function will create 9 times 9 is 81 squares in the environment in the left here. Okay, so by default is a black transparent square lah. Okay, so the cubes that's returned will be a 2-dimensional array. Then they can use this 2-dimensional array and then to change the color and the location. So of course I also provided with a class lah. So once I provide a class, I give them the two functions, set color and set location. Using these two, they can change the property of the cube. So another example here will be also, for example, height is 9. They call this function, and then let's say they use the cube 5, the row 5 and column 5 cube. I set the color to blue. So these are all the things they need to know, and they can continue to do the exercise. Really, this is the main thing they need to know lah. So over here, I use a 2D examples. It's easier to see lah. If a 3D, it will be harder to trace lah. Okay. Okay, so as I said, once they know how to use all these functions, they can now attempt the programming tasks. So next, I'll go through some of the programming tasks that I give it to them. So over here, like for the concept is about multi-dimensional arrays lah. Okay, so of course the 2D one is easy. So one of the questions I give them is how about color the perimeter of the big square here lah to red. Okay, so it's a very simple simple task. Okay, so you can upgrade to a 3D version, then just to color the surface of this big cube lah, red lah. Okay, so you can see in the middle here it's still black lah, translucent black. Okay, so this is some of my exercise lah, trying to introduce some programming concept or use as a revision. Okay, so other things we can do is iteration, recursion also can. So as you can see here, there are many parameters here lah. So as they can do a recursion, define the base case, and as every time it go to call a recursion, they can do a loop of the color change. So you can see change from red, green, black, red, green, and then if the height of these squares are more, the side of the square has more cubes, right? Then the rotation of the color will continue all the way to the center lah. And of course, they can also do in the 3D manner lah. Okay, as you can see the diagram over here. Other things that I can do is I do a read file with them because this is in the syllabus lah, H2 computing syllabus. So I give them a text file. I ask them to read this file, and then I color the cubes accordingly lah. So R means red, W means white. Okay. So once they colored it, I can also ask them to do things like rotation. You write function to rotate the heart 90 degrees. And then if they're interested, they can also do further lah, do iteration. Then they can do animation by inserting the keyframes lah. The keyframes is one of the term they use lah to create the animation. Okay, so I give them examples like a rotating heart lah. So this is one of the tasks that I give them. Okay, it's not that difficult to do because all the things that you need is all inside one Python file, and you don't have to pip install anything at all. It's all in there. Right. So next thing I will show you how some of the student example lah. Okay. So Okay, so easier for me lah, because if it is Python shell terminal, right, the text base, right, I will see letters lah. Okay, so over here I can see the color. So things like if I look at this diagram, I can quickly lah to tell my student that your color does not rotate lah. They're supposed to do this task lah, the rotating color task lah. So I can see the green color is missing, so colors are not there. Then the parameter set is at the wrong place lah, because it's supposed to be, for example, you look at the picture here, the green squares are supposed to be at the second layer. But this guy draw the second square parameters, all the parameters at reference to this square over here, this cube over here. So all we have a weird shape lah. So the advantage for me lah is that I look at the colors at the corner here. I can give them some advice lah, and what's wrong with this, and actually also we help them lah to see what is wrong, hopefully faster lah. But of course this is 2D lah, but if the question is 3D, right, they will have a hard time to debug it in the shell lah, in the output, the shell, the idle shell. Okay, so another example is this. Okay, so this is still doing the same task, the recursion task, painting the colors of the cube, like the parameters. So over here, take a look at this, you will know that the previous task they have done on the parameter is wrong. So when they draw the inner green squares, right, their code does not, is a bit wrong. So they will color override the original red cube over here. So with this, I can tell them that your previous task is wrong. That's why when you call recursion, this is also wrong. Okay, so the feedback can be given to them faster lah. Okay, like this one also, they are supposed to create this pattern here, but look at it, the second row, all the odd rows, the red cube is not colored, so something is missing lah. So that's why I can do with them, and I can give them a quick feedback lah. So as I walk in the classroom and as they do this exercise, so I try out with my student, and okay lah. So far they are not at the beginning of the lesson when they see Blender, they are shocked lah, because what, so many workspaces, so many properties, so many things to know. But actually after I go through with them once lah, then with the demo, and actually all of them can actually start doing lah. Okay, so not much of the issue after that. So don't be, I will tell them don't be afraid of the UI of Blender lah, because there's a lot of things squeezed together. But actually it's quite easy man. Okay, I put this link in the YouTube video as well lah. So if you are really interested, you can download the resources there and use it. Okay, so that is from me. Is there any questions? Maybe now.
There are some questions in the chat. Are you able to look?
Yeah, let me try.
Thanks.
Where is it? Sorry, I'm a bit slow. Give me some time. This is not.
Yeah. Do you?
Okay, so this one. How do? What is it?
I think the first one is, do you, from Dr. Oka, do you need to teach oriented first before they use Blender scripting?
Sorry, is it the processing one?
No, before that. Yeah, do you need to teach object oriented?
Yes lah, but as I say, when I create this, I'm using it as a revision to my student. But I think it depends on how you create the task lah. So you can tweak your task in such a way that it is in OOP. But I think it's harder to use to teach OOP using this lah. Okay, but maybe you still can lah. So I can create a template class, then ask them to fill up all the class function there. I think it still can. But I don't think it's a good idea to teach OOP using this. So in this case, yes lah. If they know OOP, they will be able to use my class easier lah. Yeah. Then the other question is this. I'm not too sure about what it is. What is Blender reprocessing? Because I'm also new to that lah. I just learned enough to run my lesson. That's all. maybe you can share what is it about.
Okay, I think Dr. Oka shared a link on I think it's another tool for I think visualization and animation. Yeah.
Okay. I'm not too sure. Maybe I need some time to look through that lah. But the quick answer to this is that I can't compare with this now because I'm not sure what it is.
Okay.
Sorry about that. Yeah. Okay, I will stop presenting. Sorry, is there any other things you all want to ask? If not, I think that's it from me.
Hi, I'm Teck Piao here from Montfort Secondary.
Yeah.
Got a question. So, in your search for Blender, right, was there an underlying problem that you were trying to solve by sourcing for Blender?
Underlying problem. What asking why Blender, this idea of Blender come to me, is it?
Yes, yes.
I have another lessons. Our school also have a lower set computing class lah. So we want to ask them to learn more about new media stuff. So it just happened that we have decided to teach them some 3D modeling stuff lah. So I go and learn, and it happened that Blender also, while I'm learning it, I happened that I know that I can do scripting in Python over here. So then I'll just continue with that lah. Can use it for my JC students as well. Yeah. So no underlying objective one. It just happened that I can use it. I'll just use it. Yeah.
Mr. Gee, do I have time for one question to ask?
Yeah, Prof. Leong. you can.
Yes, can. Huh? Okay. So I guess you answered that you while doing using Blender for something else, you discovered that it's also useful for your JC class. Right?
Yeah, correct. Yes.
So this is a very good example of doing A but finding that it's useful for B.
Yeah.
But I was also thinking as you were going through, have you figured out what is the big advantage of teaching with Blender? What you could have also taught with some other method? You mentioned some of this, like using a shell scripting. So what do you think is the big advantage that you gain by using Blender?
For me, not if my takeaway is that I found that the Blender software is quite powerful lah. Again, I think I enjoy making those 3D models, but not related to totally not related to the programming part. So but for me lah, it's the visualization that I think is powerful lah. Then I cannot do. Using the shell, right, I cannot do all those 3D visualization thing, but with Blender, I definitely can, and it's much easier. So you can really see the position there, and the good thing is you can rotate and see in different view lah. So that part you will know that it's a mistake or not. If you just print out the 2D matrix one by one like this, you have a whole list of matrix that is very difficult to.
So maybe it might be good for you to verbalize this to the student. Basically, what you're saying is that by visualizing it in 3D, you make debugging a lot easier. Identifying where the error is, and then connecting it to code so that you can make a correction. And I think to me that is one big advantage when you use visualization. I think. In my own experience working with students also, I have always asked my students to animate what they do, visualize and animate, because then they can pinpoint. Whereas typically they use debugger, they use all these things, and that's very low level method of debugging. Okay, yeah.
Okay, thank you.
Thank you for.
Thank you. Yeah.
Yeah, thanks very much. We need to move on. Yeah, so thanks Mr. Chan for sharing. Using this alternative tool to make students visualize and hopefully understand the programming concepts better. Right. So our next speaker is actually probably the most regular. Right. So when we started PyCon SG Education Summit in 2015, he was already the one of the most enthusiastic presenters, right? And ever since, I think he has not missed any of these education summit, right? So yeah, so that's and today is actually going to not give one but two talks. Yeah, so a regular talk. So let's hand it over to him. Yeah.
Okay, thank you, Mr. G. Just want to check, can you all hear my voice and see the screen?
I can hear your voice, but I think you need to share first.
Let me see.
Oh yeah, okay.
I can see.
You can see the screen? Okay.
Yeah.
Thanks.
Yes. So my presentation is not as fancy as the other two, which I really like it. I really enjoying it. Because I think AI, machine learning, also something that is close to what we are teaching, even in the first year in SUTD, and even how to visualize it. I think Dr. Norman is also here. Our course in the first year is actually using like Rhino 3D and also with Python on the second half. But my presentation here is something that is more basic, but it's also close to my heart because I've been teaching like novice programmers the first years, and I've encountered some like difficulties. And this is like one framework that we are using in SUTD. You may feel that it is natural and familiar, but I would just like to show you on the rationale why we are using it. Right. So just like one paper that I dig out, but there are many papers in computing that talks about difficulties for novice programmers, and I think it's quite acknowledged that learning programming is actually difficult. And I personally noticed this because in SUTD, all the first year students have to learn programming, right? So either they go to for computing or they go for architecture. They have to go through this course. So I think the background make it more obvious the difficulties of the novice programmers. And some of them are not motivated to learn programming, for example. Right? But this paper actually shows a few things, like some of the abstract concepts. Something like visualization actually can help to teach some of the abstract concepts. But what I'm interested for this presentation is actually on the other two boxes there on the left, which is that many students know the syntax of Python, like or programming languages, but then when they have to write the program, they always find it difficult. They do not know how to start writing the program, right? From the problem descriptions until the final working code is like a big jump for them, right? Similarly, like they understand some of the basic concept in programming, iteration, all this kind of thing, but when they have to start using it to apply to a particular concrete problems, it's really hard for them, right? And so I think this paper suggests a few things in the learning materials. Like we need to also gear the learning materials towards like program generation, how to write code, how to modify code, about the debugging skills, which sometimes like we don't really pay much attention on this. But if you look into this tree, it's actually something that when you go for programming interview in the industry, they actually are doing this. Yeah. But I think when we look into the literature, we realize that there's a lot of things in the novice programmer's mind, and this is what they call as the cognitive load for a novice programmers. They don't just like learn the programming language syntax, which sometimes we focus a lot, but they also need to use problem-solving skills. They need to be able to solve problems, right? And not only that, but they have to learn about the IDE, right? You can imagine if the IDE has a lot of debugger, tools, button, different windows, and all these kind of things. As a novice programmer, they have to be able to handle this software. And that is separate from problem solving. And it's also separate from the programming language syntax. There's also like some computing concepts like array, list, or even if you teach something that is more like C, you talk about pointers and all these kind of things. So there are some concepts that they have to deal with, and then they have to learn the language itself. They have to learn the skills of problem solving. And then when they have problems, they have to be able to debug it. So that's like another different kind of thinking. And these are like all the thinking skills that actually we require them, or at least in the first year university programming course. But sometimes we only focus on a few areas. For example, we don't teach how to use the IDE, or like we teach the programming language, but we seldom teach how to debug things, right? And that requires sometimes like one-to-one tutoring or mentoring. So there are certain things that we don't actually put in our explicit content materials. So the one that I'm interested in is actually on the problem solving part, on the problem solving here, right? And one of the things that we are trying to look at, can we reduce the cognitive load of students and help them in their problem solving skills, right? And so problem solving framework has been around for many years. There was this book by Polya since 1940 something. It's actually from mathematical methods, and basically is teaching people how to solve problems, right? And I think the context is actually from math, but the steps have been followed since then by even like for computer scientists. So first you have to understand the problem, you devise a plan, and then you try to carry out the plan on how you solve your math problems. And after that, you reflect, you look back, right? You look back how you solve it. Is there another way of solving it? You check again and all these kind of things. Right? And similar framework has been used also in computing. And we tend to use from software engineering perspective, like you have like requirements, and then you started to breaking it down, right? Then you started your design of your software, modularize it, break down the big problems into smaller problems, and then you started implementing the smaller problems, and then you test it, right? So this is like the kind of the 4 steps of problem solving that we tend to teach in the programming course. And most of the time, because of I think the way that we take from software engineering, we tend to do a top-down approach. So in the sense like, okay, I know the problem, and then we start to generate sub-problems. We try to modularize it. And when we try to modularize, basically try to divide and conquer, break it down into smaller problems. And then once you have a small problems that you know the solutions, then basically you transform that into the solutions, right? And then you try to recompose everything, you evaluate again, and then basically this is like an iterations, right? You look into again the next problem, breaking it down again if there is any, and then once you found the solution for that particular small problems, then basically you write the solutions for that, and then until everything basically become one solution that is working, right? But for novice programmers, this is actually a hard thing to do, right? This is actually a hard thing to do. And one of the things that is hard, because when you try to look for the solutions, and I think there's one paper by Loksa, he gives like a 6 steps framework for problem solving. One of the steps is when trying to find the solution for a problem is actually by using analogy, right? So even for Polya, one of the things in math, when you're trying to solve a math problem, is that he will ask you, have you seen it before, right? Have you seen like a similar math problems before, right? So through that similarity, hopefully, and because you know the solutions, then maybe you can try to work it out something similar. Similarly, for Loksa, I think one of the steps is actually search for analogous problems. And so I think the idea is that they have to have like some solutions bank in their mind, right? And there's some paper that is showing the difference between novice programmer and experts programmers and how they think, right? So the expert programmers, basically they think in terms of these so-called schemas. For this new problem, what is the nearest problem that I have seen before? And then I'm going to work it out from there. But the problem with novice programmer is that they don't have these schemas, right? So like the picture on the left, I think is like giving the image of an expert programmers. They have seen a lot of problems. They have worked a lot of programming problems. And so when they see a new problem, okay, this looks like requiring iterations. This you need to check these conditions and all these kind of things. This looks like you can solve it by searching, and they learn different algorithms of searching, so they know like different ways of doing a search. However, the one on the right there is like an empty shelf, and I think that's what happened with novice programmers. They don't have a mental schemas of different solutions and how like the new problem can relate to what they have seen before, right? So that's something that I found, and I think many of us, the instructor found, that students tend to get stuck when they try to approach a problem when you just give it the problem statements, right? So what we are doing is actually we are trying to frame it in such a way that there are clear steps, where every step is actually trying to bridge the thinking from one to another, so that the gap becomes smaller, right? And one of the reasons is that to use this so that students have different solution schemas. But when the schemas are empty, we have to build it from the bottom up. Okay, so I think there's another paper that is talking about that. For the novice programmer, you cannot assume that they can find the analogous solutions from the previous problem they have seen. You have to build up the schemas from the bottom up. And so we work out this so-called PCDIT framework. And the idea is that how can they build the schemas from basically the bottom up, right? And so we come up with these abbreviations. P is basically for problem definitions, C for the concrete cases. So they have to work out the concrete cases first before they actually design the algorithm, right? And we actually separate the design of algorithm and the implementation separately, because you can think of the steps before actually you can think of the particular syntax in the programming language. And that actually reduces the cognitive load, because you don't have to worry about, okay, what functions in Python I have to add into a list, for example, right? You can just think, okay, I just want to add it into the list, right? And that reduces the cognitive load significantly. And then we're going to show that this is actually like an iterative, especially on the implementation and the testing. So on the subsequent slides, I'm just going to show you a few like worksheets that we use, and how we use it like on the different problems. And hopefully you can see that it actually bridges the gap from like problem definitions into the implementations. Yeah. Right. So this is the first example, the first step, which is problem definitions. And in every problem solving, either it's math or even in the computing, they always start with the problem definition. And one of the things that they usually ask is actually you have to identify what's the input and what is the output, right? And in one of the textbook, actually they ask you to identify what kind of data is the input. And there's sometimes that we seldom ask, especially with Python, because Python is dynamic binding, and sometimes like you don't really ask questions about what is the data type. But one of the common mistakes of novice students when they learn Python is actually they assumes this variable is of this particular data, but actually it's not. And so like some of the function like doesn't work, all these kind of things. So asking questions about the data type is actually important even when you start formulating the problems. So this is an example like to do functions to do matrix multiplications. This is a matrix. You specify this is a list of lists, certain dimensions, and so on and so on. This is another example on the bottom right here. It's basically given a list of numbers, write a function that only return a list of positive numbers, right? So what is the input? It's a list of numbers. The output is just a list of positive numbers. And the process basically just trying to summarize it in one sentence. So having that summary is actually helps them to keep track. Okay, this is what I'm trying to do. This is the final goal. This is the thing that I'm trying to do. And from that problem definitions, the thing that we are trying to tell the students is that you don't write the code immediately. And I think sometimes students are very impatient to write the code. But we realize that sometimes slowing down is actually helps the thinking a lot and significantly. So what we're trying to ask the students is actually work on some concrete cases, right? So in one of the famous book, How to Design a Program, there's one step called functional examples. So it's actually encouraged that students work out with particular examples. And this is like, in the left here is actually a particular example. So when you multiply two matrices, right? So you work out, okay, two matrices with different dimensions here. You show how it looks like. And then how do you get the final output there? And then you can work it out. Some may work with like these indices. Some instructors, they realize that sometimes these indices are confusing. They use like arrows to animate it to the students. But the idea is that asking the student to work it out manually, right? To work it out manually. The one on the right here is from the same problem that I showed previously, which is to get a positive number. So you have a list of input, and then you want to get a particular output. So you show the animations. Okay, is this positive, greater than 0? If yes, I'll put it into the list. If not, I will not put it into the list. Then I will move to the next one. Is it greater than 0? Put it into the list. If not, I will not do anything, and so on and so on. As they work out the examples, actually, so this is the book that I mentioned, How to Design Programs. So one of the steps is actually functional examples, right? And I think the idea is that as you work out the examples, you can write it down, right? You can write down your thinking process as you work out the concrete cases. And that actually bridges the steps on how to start to write the code, right? And this writing down of the step does not have to be refined yet. It doesn't have to be like some of the pseudocode that is very similar to the programming. It can start with simple things that they show their thinking process, right? even if you look into this algorithm, there is no like for loop mentioned here. They just mention it, okay, continue do this, right? Repeat doing this until the end of the list, right? And then at the end return it, right? But then the idea is to refine it, okay? So in the worksheet, we actually give a suggestion. You can refine the algorithm, identify the patterns. Is there any repetitions? If there's any repetitions, can you structure it in such a way that that you can write it in a more look like a code, right? So the one on the left here, also this is the problem of matrix multiplications, right? So if you look the one on the left there, it's more like less refined, right? Okay, so for each element in the first row of A, you multiply it, and then you sum them up and all this kind of thing. And then you see that there's repetitions. You see that the same thing is being said again and again and again for like 2 times, and then for the same 2 times it's being repeated again on the last 2 lines. And then you can say, okay, you can do these steps for every column in B. You can do this particular 2 steps in every row in A. So identifying the patterns. And then you can refine it to something that's more look like on the right side. This is not Python code, but if you take a look there, you can see the structures of something that's more similar to like a Python code. You begin to see, okay, for the number of rows in A, do the following. And you can, later on, you can immediately map that to your for loop statement and all these kind of things, right? So for the number of rows in A, well, create an empty list. And then for the number of columns in B, do the following. For the number in this, and so on and so on. So the idea is to refine this design of algorithm to something that is more closer to what you would implement in a Python code. And once you have, so the one on the left here is the one that you saw on the right side on the previous slide. From here to the Python code, you can see that the bridge is closer, right? You can see that the bridge is closer here. And you can see that for the number of rows in A, you can put it for row in range, row A or whatever that is. And then you can, create empty list. How do you create an empty list? So this depends on the programming languages. In Python, you can just create empty list, something like this. For the number of columns in B, then you can write how to get the number of columns in B. Then I will do the following and following, right? So I think the idea is that if you start directly to the code itself, it can be very overwhelming for the novice programmers. And what we're trying to encourage the student is actually to slow it down, to think through it, to work it out from the bottom up, from the concrete cases, to look into the steps, identify the patterns, to refine the patterns in your design of algorithm, and then after that map it into the Python code. All right. So there was this also paper which I just heard about it during the last CTE STM conference, which talking about the sub goal labeled. So basically, if you label your instruction materials with your sub goals, actually helps to create a mental model in the learners, right? So the design of algorithm, you don't have to write it in a paper, for example. You can actually write it as a kind of commands. And you can think of it like a sub goals. Okay, so the first sub goal, I have to create an empty dictionary, or the next sub goals, I have to split it, or the next sub goals, I have to go through all these kind of things. So they don't have to bog down with the implementation yet, but by looking into the steps, that actually helps them to create a kind of mental solutions, right? Regardless of what programming languages that they are going to implement later on. So that actually helpful, and that actually promote the creation of mental models in the learners. So this is another example of I think this is an example of matrix transpose. So over here, for example, the instructor use like arrows, like small arrows and big arrows to work through how to get the output of the matrix transpose, right? And what he does, like he actually work it out the concrete cases, starting from an empty list. You put it in, okay, you get the first row. Empty list, you put it in, you get the second row. You put it in, then you get the third row. And that actually helps also on the implementation and testing, right? So when you start implementing it and you start to testing it, you can actually, and the student can actually see that actually what they got is correct because that is what they are working out in the concrete cases. So for example, they see all this output 1, 1, 4 on the output statement here when they print it out. And they see like this 2, 5 is being added after the 1, 4, and then they see the 3, 6 also being added subsequently as they start implementing it. right? So I think that helps them to be more confident, and we actually tell them to write code incrementally, step by step, print out, check, and all these kind of things, right? So that's the iteration between the implementation and the testing. So just now we talk about, for example, from the design of an algorithm here on the blue circle on the top right to the implementations is actually a closer gap rather than just telling, okay, we need to transpose a matrix, and how do you start, right? So working up the concrete cases helps them to write down so-called the steps over here. For the number of rows, I will do this. And in fact, they don't need like indices over here. They can use, okay, the row is actually pointed by the big arrows because they look into the picture here. That's the one is pointed by the big arrows. The column is pointed by the small arrows. And in fact, in the code, they use like small arrows and big arrows as the name of the variable, right? So which I think it helps the students to keep track of what they are doing. And I think that helps them to understand how the working of transposing a matrix in these solutions. This is another example of another instructor. So we mentioned about the worksheets, but you don't have to do it like in different pages. So for this instructor, he actually overlapped the different steps into the same page. So he started with the concrete cases, and then he started writing the steps in that same concrete cases. And then after that, he started writing the code. And then after that, he summarized it, everything else again in a final page so that it's cleaner to see, right? So this is the worksheet that we actually use. So we start with the problems. We give them like a short description on how you should do it. But I think modeling it by the instructor is the most effective way so that they can see what it means by doing the input-output. You have to look into the data type and all this kind of thing. Working into the concrete cases, how do you work it out? Sometimes you need to use arrows or whatever that is. And how you refine the algorithms here using certain keywords that is more similar to Python. And I think that's the advantage of Python because the language is pretty English-like. So it's easier to transform from the pseudocode into the Python code. And then you iterate the implementation and the testing. You look back into the concrete cases and you can see that you're progressing into your solutions. So I think this is the last few slides. So one of the things that we recognize is that we need to provide metacognitions. And this paper actually shows that if you train the students in their metacognitions in problem solving, it helps them to solve problems, right? And one of the things that actually they do is like they actually use like physical token to tell the students where you are at your problem solving. Are you doing like step 1? So this is the one that's doing like the 6 steps framework. So are you at step 1 or are you step 2 or are you step 3? Simply by knowing where you are in the problem solving, it actually helps them to think through and it increases their problem solving skills. So I think that's why we try to name it in such a way that it's easy for students to remember, like PCDIT, because then it's easier for students also to recognize where am I in my problem solving, and then it helps them in their metacognition. Oh, okay, I'm stuck from the concrete cases to the design of algorithm, or maybe I'm stuck from the design of algorithm to the implementations. Then they know, for example, their weakness. For example, maybe they're not familiar with the syntax yet, and then maybe that's the area that they need to strengthen with, right? Or maybe they're a bit weak in terms of, you know, from concrete cases to the steps. Then they need to learn their problem solving, recognizing patterns of the steps that they are doing and all this kind of stuff. So that is actually to help them to look through into where they can improve as well. So this is my last slide. So I think the idea is that sometimes we take for granted that we just need to teach the programming language. But actually for novice programmers, there's a lot of things in their mind. So one of the suggestions in the many studies is actually to reduce the cognitive load of novice programmers. You can use a simpler IDE. You can give a template of solutions and just working out on different things. And I think one of the things that we are interested in is actually how to increase the problem solving skills of students from a bare problem descriptions into the implementable code, right? And I think we try to create these different steps, clear steps that they can remember easily so that they know where they are, that increase the metacognitions, and hopefully they will help them to increase their problem solving skills. Yeah. Okay, so I think this is the end of my presentations. If you have any questions, I can try to answer your questions.
Thanks very much, Dr. Oka. I think we can take one question before we go for the break. Yeah. Or else we can also take the questions in the chat. Right.
Sure.
Yeah. So if everyone is okay, the time now is 3:21. Maybe we can shorten the break a little. Yeah, because we are already overrun. And we can come back by maybe 3:27. Yeah, 3:27. Yeah. So then we'll continue with the second part. Yeah. Okay. Thank you.
Oka, since we are on the break now, okay, I like your presentation. It brings back history from 25 years ago when I did curriculum design, and we look at all those issues that you mentioned. Have been studied before. We use a similar thing. Okay, yeah, and these are very standard things. One of the reasons is that university courses are designed, okay, so that one module you cover a lot of ground.
That's right.
Okay, and then you mix things up, and increasingly newer textbooks have forgotten how to do the dichotomy between problem solving, design the algorithm, and then the actual translation into any language. Okay, if you look at a textbook from 40 years ago, 30, 40 years ago, there is no language. They are always written in pseudocode, so that it is an algorithm. And you can then later on decide how to do. Then there is a clear separation between problem solving and how to translate it into whatever is your favorite programming language. And I did train students the right way, because in the end, programming is really about how to design an algorithm. How do you figure out all the loops and all these various things? And I think somehow that have taken a back step. The newer textbooks have all start talking about syntax and all these things, and that's all wrong. Okay, all right. So what and that's why all these papers come out, because they get all messed up. Okay, and they start coding. And long time ago, I have one solution for you. Take it back to the time when you have to design punch card, and every card they punch cost them money.
Yeah.
In other words, I told students the very best way is every time you compile a program, I'm going to charge you $10 every time. Now they just do press before they even finish. There are 3 mistakes, they correct one, they compile again. Another one, they compile again, right?
So trial and error.
And hope that, pray that it will work. Okay, but they never. Okay? So basically, I think those problems that you mentioned, we have. And we also tried, I remember, 20-something years ago, I did the same thing. Give them the problem statement, okay? Get them to work through many examples, and I don't let them touch the computer. Okay, it was easier at that time because we were using terminals. Okay, they don't have their own PC and all that thing. Okay, they were only using terminals. Okay, and we did all of that. Okay, and also I think you need to also understand that there's only that much you can teach about problem solving.
That's right.
Okay, to throw everything into one course, maybe too much. Okay. Yeah. Killing so many things in one course and package it together. And increasingly, you have IDE and all these things. All these things just complicate things. They can always pick up IDE once they're comfortable with it. It's almost like you learn a bicycle. The bicycle comes not only with a bicycle, we have extra basket, and so on. And you say, okay, get on the bike. And what does the kid do? Which are the control, where is this thing, and so on. Okay, give them very simple. I remember I talked to a very senior professor at that time, and he said, okay, I'm going to only use this editor, just very simple, basic, plain text editor, okay? And your program better compile on this fella, otherwise, no fancy IDE. If it doesn't compile on my thing, even if it work on your IDE, you're still going to get a big fat 0. And I think these kind of disciplines are useful in helping, okay? Focus on the simple thing, get them to do the thing well. Then later on, the IDE can come in. Okay, this is one area where I think Kenny, Joe Ming might remember. Okay, when we use Scheme, we use a very simple editor. It's very plain, nothing very much, no fancy stuff.
And I'm
But
still
it works
using
very well.
nowadays. I'm still using it nowadays.
Yes. Okay. All right. But of course, Chobing's one was by that time. Okay, we have already moved. Okay, into this new curriculum and all that. But all these issues are well known. They are valid concern. Okay, and okay, but there are solutions known. Okay, and I think instructor need to be forceful sometimes. To prevent them from paying the attention to all the wrong things, how to set up IDE, how many spaces should the tab be, and so on. Let them worry about that thing when they become really great programmers. Okay, but get them to think about problem solving. Okay, and then the translation. Okay. All right. Sorry, I talked too much. Yeah.
No, that's very true. Yeah, I mean, I'm guilty of this also because I'm inheriting from this newer textbook and all these kind of courses. Yeah.
Yes. Yeah. Thanks very much for the discussion. Yeah. So we are now back to the second part, and it's mostly actually from students, right? Because since it's an education summit, for probably the longest time we have focused very much on educators, right? But I think nowadays, especially in the area of technology and programming, right? Sometimes our students have also very much to teach us, right? So the first talk after this break, after the break will be okay. I need to share the slides. Yeah, this is a pretty interesting speaker, right? Right. So why do I say so? Right. So the talk is titled "The Swordtale Story: My Experience Learning Python in Building a Discord Game Board," and it's actually by Mr. Elston Tan, right, from Bukit View Secondary School, right. So let's get him to introduce himself and start the talk.
Hello, do I start now?
Yes, please.
Oh, okay. So hello, teachers and professors. My name is Elston, and I'm currently an O-level computing student. And today I'm going to share with you my experience with self-learning Python all the way to developing a Discord bot. So Swordtale is basically an MMORPG, which means massively multiplayer online role-playing game, and it's played using a bot on Discord, and it's quite a unique game bot because most of the well-known bots or most of the bots on Discord uses a turn-based turn-based mechanics for their battling stuff. So for example, like the player and the monster will take turns hitting each other, whereas for this bot it's more of a cooldown mechanic where a skill takes has a 5 seconds cooldown. So it's also a learning experience because this is the first time that I've actually worked with people on a project as well. So right now we will I'll be showing a bit of the demo on how the bot works and some of the features. So when the player comes into Swordtale, they'll basically start their game. They'll basically have to enter in start, which is one of the commands to start their profiles, and there'll be 5 races for them to choose from, and each race has disadvantages and advantages, so each of them are unique. So when the player chooses a race, they'll be prompted to enter their username. After they enter their username, they can see their profile by doing comma player, which is another one of the commands. So you can see that they can see their status, gold, race, level, coordinates, location, guild. There's a keybind and skills as well. And the keybind just basically means that that particular character corresponds to that particular skill, so they can use it in battle. So they don't actually have to type punch, but they can just type E and then it will correspond to the skill punch. So the coordinates and location, currently I'm in a town and there's actually a map. So it's kind of hard to read for like right now, especially with millennials. And basically there's also town information. The player can see the information about their town. So it sort of provides a brief description of the town, the non-playable characters and the locations there, and it's also actually interactable. So if they interact with one of the non-playable characters, there's just a short dialogue and they can actually interact with the locations as well. So it will sort of give description of the surroundings. So for example, in here they'll say like you make your way inside the empty lighthouse. The interior is really spacious and quite desolate, and then it will sort of give some actions for you to take. So they'll say like, what will you do? Go up the stairway. So there's only one option, and it's quite interactive. And then in this case, you can either read the book on the table or read the note on the So that's for the interactive towns and stuff, I guess. So the next thing I want to show is the battling stuff. So when the player moves their position in the map, when they are not in the town, they can actually fight monsters, and it actually asks them if they want to fight a certain monster. So it generates that monster first, and if the user thinks they cannot defeat the monster, they can just say no, and then sort of move on to more easier monsters to fight. And basically the monsters actually have cooldowns as well, so they'll slowly attack you, and as I've said just now, the keybinds corresponds to the skill. So if I type E, you can see that it says you use punch to deal 2 damage to the monster. So that's how the battling mechanism sort of works basically. So yeah, that's all for the demo, I think. So the next thing I want to show is the code actually. So one of the core features of the game is the battling, because of the mechanics. And basically, if we scroll down to line 570, I think, there's actually there's 3 coroutines in the battling mechanisms, and it's using async IO as well, the program. So if we scroll down to line 570, we can see the first coroutine, which is task battle. And basically what task battle does is it has a while loop, right? So for every loop it does, it actually calls another coroutine, which sort of calculates the damage that the monster does and minuses it from the player's health before outputting that screen that you saw just now to inform the user of how much health he has now. And then it sleeps and sort of passes control. So if we scroll all the way down to line 731, there's the second coroutine on line 731. The second coroutine would be, it's line 671. The second coroutine would be message attack. So basically what message attack does is it's responsible for, it has a while loop as well. So for every loop, right, it gets the user's message, and it only gets the user's message if it's one of the keybinds, and it's responsible for sort of attacking the monster. And when the user enters a keybind, it calculates the damage that the player does and minuses it from the monster's HP. So that's what that does. And it also adds some buffs. Like for example, if you use punch, you get plus 20% strength, something like that. So if we scroll down, the third coroutine would be second check, which for every loop it does, it basically checks for if the player or the mob is dead, and if they are dead, it will cancel the two other coroutines, effectively stopping the battle. It also checks for if the buffs expire. So just now the plus 20% strength, it will have a duration, of course, and it checks if the duration is up or not and sort of cancels it. So that's sort of the battling mechanics, I guess. So yeah, moving on to the next one. My first Python program or project was actually a love calculator, sort of. So love calculators, you input two name and it generates a random percentage, stating how much the first person likes the other person. And basically, I did this when I was in Sec 3, my first Python program basically. And so there's a video of it actually. So over here, you can see that the program prompts for the first name, and I basically put in the first name and the second name, and I was teasing my friend because back then I was immature, so I used to tease my friend that he likes a girl, and you can see that it's 100%, and it's always 100% instead of a random percentage, because back then I didn't know how to do random stuff, and also I wanted to tease my friend to say like he likes that girl, like yeah. So that was my first Python program or project. So some of the learning resources I used was when I started Python, I got quite interested in it. So I searched up Python tutorial, if I remember correctly, and I chanced upon W3 Schools, which is really good for beginners as well, because it's really it explains different functions and stuff thoroughly, and it's also very simple, so beginners can easily understand different stuff on Python. And also I remember I slowly started doing projects. So for every function that I read about, I would experiment around with it. And for every 3 or 6 functions, I would do a small project incorporating all of the functions that I learned, so that I actually understand the what the functions do and stuff like that. So I remember small projects went to big projects. And during one of the projects, I didn't know how to do something, and I couldn't find it on the internet, or the answers on the internet either. So I had to go to the Python Discord, and I asked on one of the help channels, and I met this one guy. He helped me, and I remember I said thank you in his private messages, and from then on we somehow became friends. And he always helped me out as well. So I would ask him different questions about my project if I had any, and he would explain it to me. Like he would give me a very in-depth explanation, which made me like learn even more basically. And he slowly started becoming busy. So he instead introduced me to Stack Overflow, which I use to this day, and it's every programmer's best friend. So those are sort of the learning resources that I use. So there's some difficulties in developing Swordtale, and of course everyone will have bugs when developing stuff. So I'll talk about one of the biggest bugs that I have. Other than careless mistakes, there was a bug that was quite interesting, because when I was developing the battling mechanisms back then, everything worked perfectly fine. But the code wouldn't continue after all 3 coroutines were stopped or sort of cancelled. So yeah, if we go to Python tutor, I actually didn't know how to solve this, so I searched on the internet and I actually asked in the Python Discord as well, but I had no answers. I couldn't get any answers, so I just had to I had this idea to make a smaller scale program for that that works sort of like the battling mechanisms. And as you can see here, right, so the first coroutine is supposed to be for I in range 10 print I, quite basic. The second coroutine is for I in range 20 print I, but if I is equals to 10, then it will cancel the first coroutine. It shows a cancel error, which is what was missing from the Python interpreter back then when we were working with it. Because back then the Python interpreter didn't show that cancellation error, which was supposed to show and showed in the Python tutor, which was where I found where the error was. It was that was the problem basically. It just didn't show on the Python interpreter. So some of the other problems were I realized that making game development, it isn't only about coding. And basically one of the other problems I ran into was that the output looked ugly. So from just now's demo, you could see the outputs showing the players' leftover health and stuff, and the output no game is no game would look good without any graphics, right? So I had to actually learn a bit of pixel art creation to sort of make the graphics, to make the game more appealing for the players' eyes. So then there was the story and dialogue as well, because my as I said, my game is an MMORPG game. So it has a sort of a story behind it. And I realized that storytelling was also an important factor in at that aspect, because I actually look back on some of the stories, and just now as I've shown you could interact with the town and some of the non-playable characters, and I actually look back and I remember I found it really weird, and I sort of cringed a bit at it. So yeah, I found out that storytelling was important as well. So my future plans for Swordtale, currently it's in the second version of its alpha state, and I plan to make more content in it. So like stuff like multiplayer battling and at least 10 people fighting one single monster together. So there's actually cooperation, tactics, strategy in it. And I plan to officially release it to the public when beta is ready and heavily advertise it and stuff. Yeah, but I'll also still be studying for my O levels, of course. My advice to other Python learners is that it's well, people have different learning styles. Everyone has different learning styles, and the thing that's common with programming is experimenting. One of the ways to learn effectively with programming is to keep experimenting. And there's no risk in experimenting. It's not with chemistry it's not like chemistry where if you mix two things, it might explode in your face or something. So just play around with some of the functions and stuff, and that's the best way to learn, I guess. So thank you for listening to this presentation. I think the slide deck will be given. So if you want to play the game or try it out or learn more about it, there's the link, and then my contacts are there as well. And I'm actually looking for people to collaborate with, or collaborators, because right now I'm the only one working on it, because the two other collaborators they're of course helping, but they're really busy with their exams and stuff right now. So yeah, if you want to collaborate, I guess just tell me or something. I don't know. Yeah, thank you. Yeah.
Okay, cool. Yeah. So any questions for Mr. Elston? Right. So yeah, you probably some of you realize that I'm actually controlling the presentation for him. Yeah, I was pretty impressed because Mr. Elton is actually when we have online meeting, he's usually using his mobile phone. And when I asked him, "Oh, why don't you share your code directly on your computer?" Or he say, "Oh, actually the code is too slow to show, or rather is he couldn't quite use his laptop to show. I mean to go online for video conferencing and to share his code because he's actually using a 15-year-old laptop, right? So despite all this, so often he has to switch between his mobile device and his laptop to show us the code, right? So to me that is really a passion-driven learning, right? Because despite the infrastructure, he is still persistent, right? So definitely, we wish him all the best, and he will definitely be one of the more successful stories for Singapore. Yeah. Okay, so feel free to yes, he's O-level computing student in Bukit View Secondary, Boss Wong. Yeah. So anyway, let's move on. If you have any question, of course, please feel free to also leave leave your question for him in the chat. So our next speaker is also a student, also Sec 4, from Dunman High School, and he'll be sharing with us how he organized a program to help promote AI literacy to high school students. Right. So Mr. Nam Ting, yeah, you can share your screen.
Okay, hi everyone. I'm Ting, and yeah, it's great to be here. Thank you very much for this opportunity. I am so I'll be here today to share about my journey promoting AI literacy and my journey in Building Blocks 2021. So first of all, I would like to introduce myself and let you all know more about me. I am a Dunman High student, a secondary 4 student, and I'm in the executive committee of the Infocom Club. I joined Dunman High in 2018 as a year 1 student, but mid-2018, I actually moved to Dubai due to my father's overseas assignment. It was a great experience in Dubai, and I was a computer science leader. We came together to host a few showcases, for example, letting students see the breakdown of a computer, etc. And at a point of time, Dubai also had the Expo 2020. So I had an opportunity to work on a Unity app under their innovation program. So moving on to Singapore, my experience in Dubai pushed me to explore my interest in computing after I rejoined Dunman High after the first circuit breaker in last year. And this year I managed to share my coding spirit in Infocom and also a Python course which we hosted to less privileged students. But today I'll be here more to share about my experience in Building Blocks 2021. And yeah, being invited by Mr. Gee came as an honor. And at this point of time, I'd like to thank you, Mr. Gee, for inviting me. And surely teachers, you have much more experience, but I hope that my role as a student organizer will be able to present a new perspective to this event. So very sorry for this. Yeah, so first of all, I'd like to introduce more about Building Blocks. Building Blocks is, which we term as BBCS, it's a year-long outreach program for students by students, which we host. And one of our main events is the June conference. So this year, the June conference lasted for a week until 4th June. And this was held in conjunction with the CTE STEM conference for teachers, as well as one of our partners was AI Singapore, which helped us host a competition, which I'll mention later. So in Building Blocks, I was both a workshop speaker and an event coordinator. So I'll be sharing both of my learnings. So before I touch on my opportunities as an event coordinator, I'd like to go through my experience hosting a workshop. So I conducted a workshop with my friend named Min Jia, and it was Intro to Machine Learning. So basically, we wanted to provide the theoretical knowledge towards machine learning and hopefully spark the interest of participants. Let me run you through my workshop. We used Teachable Machine, and Teachable Machine is this software by Google that allows us to classify photos, and it served as a platform for us to introduce machine learning. So this is a demo recording, and what I did was that I chose the image project because I want to classify images. In this case, I recorded some data sets for me to use. And this was me yesterday trying out the demo again. And so what I wanted to do was that I wanted to record my face, and I wanted my head pose in a few different directions. In this case, I'm looking just straight into camera. I want a sort of neutral pose. And afterwards, you can see what I'm trying to do when I move on to this. So afterwards, I came up with 5 classes of photos with me looking in 5 different directions, which was up, down, left, and right. And this was the demo inside our workshop. So the first session, we covered more of the algorithms, while the second session, we covered more of the implementations of machine learning. In this workshop, so I came up with 5 classes of photos, and each one of them I tried to move a bit so as not to overcorrect the model. And I trained my model. Afterwards, I exported it, and in this case, I want to use it in Python. So what I wanted to use and come up with this Keras model, so I exported it as a H5 Keras model. And what I want to come up with is that I want to use this model to move my mouse. So for example, if I look upwards, I want to expect my mouse cursor to move upwards. And if I move, if my head pose is downwards, I want to move my mouse downwards. And I thought it was a pretty interesting project that we could introduce to students. Thus, I came up with sharing my code now. I'll be going through Python code. And so this very first part, we implement quite a lot of modules. We import TensorFlow, we import time, we import PyAutoGui, which I'll use later. And I turn on my web camera, I set up my labels, as well as I load the model from my library, which I downloaded from Teachable Machine. Afterwards, I basically took a snapshot of my camera and flipped it around, resized it, normalized it, and I loaded it into an array. So this allows me to run my prediction and predict what my head pose, where my head pose, where I'm looking at. Afterwards, I map this prediction and I use PyAutoGui. Right here, I'm starting to implement PyAutoGui. PyAutoGui is this module that is allows you to automate some processes in your computer. So in this case, I used it to move my mouse, and I get the current position of my mouse, the X coordinate and the Y coordinate. Afterwards, I implement it. I print out my prediction for debugging purposes. And if I'm looking straight into a camera, I don't want to move my mouse cursor. But if, for example, I'm looking to the left, I want to move my mouse cursor. So in this case, I'm decreasing the X value of my mouse while keeping the Y value of my mouse the same. So my mouse cursor moves to the left. And I do this implementation for when I'm looking right, down, up again. And for right, I'm increasing the X value. For down, I'm increasing the Y value, and so on and so forth. And this is me yesterday trying out the demo again. And there were quite a few errors again, but managed to debug them. And so you can see that what I've done is that I managed to print out both the prediction, overall prediction, and as well as the percentage in which the confidence of the machine model. Thus, you can see the very first one is neutral, second one is up, third one is left, third one is down, fourth one is left, fifth one is right. Before we continue, I want to share that this project was adopted by an article online, and we thought that, oh, this was a good way to showcase Python coming together with AI. However, we didn't encourage the students to follow exactly what we were doing unless they had the PyAutoGui module installed, because a lot of them might have faced installation issues. So we suggested that the main focus was just that how they know how to implement the model into Python. And because machine learning, Python is so versatile. So by implementing this machine learning model, it allows them so many possibilities and not just moving the mouse cursor. As I'll show later, I actually managed to do a demo of me playing an audio file by just me moving my head. And maybe we could do a lot more calculations or a lot other processes through Python as well. So we wanted to show the versatility of Python in this case. So continue on with my demo. It takes a while for the frame to load, and my face looks really bad there, but you can see that when I'm looking down, the prediction is down, and my mouse cursor moves down. When I'm looking to the left, my mouse cursor moves to the left. When I'm looking right, my mouse cursor moves to the right. I think my mouse cursor is kind of hidden right here, unfortunately. But yeah, I did manage to show up, and so this was me implementing my model. And another implementation that I did was instead of doing moving to, as I mentioned earlier on, I want to play and pause music. So I used PyAutoGui to press play pause, and I had music playing in the background, and it managed to trigger the audio going. So this was the workshop that I covered, Intro to Machine Learning. Other than that, we had a lot of other workshops in the building blocks. And these are some of the workshops. I will share the link to our YouTube later, which you can go on and catch up with some of our streams of our workshops right there as well. Now I'd like to move on to the learnings that I had during these workshops. So the first one was how we could adapt the pace of students, because this being a virtual workshop, it was really difficult to judge how fast or how slow students were going. And I now understand the pain of you teachers, because we were practically talking to a black screen, and asking us to turn on cameras many times is surely very difficult. So this was one of the learning points that we had. And mainly participants were stuck debugging code problems, or a lot of them had different processing speeds for software. For example, a lot of them had problems with the teachable machine because their computers might have been slower. Sending participants into a breakout room was one of the options we considered, but it could be disruptive to the workshop flow. Hence, what we did was that we, because we used Discord as our platform for communication, we set up a ticketing system there, and we, with that, students can open their tickets and they can clarify any queries regarding the competition, or regarding if they need to seek any debugging help with organizers. And with that, we had actually in one of the harder workshops, face recognition with Python, we had quite a few tickets open. And I'm glad to say that the workshop speakers managed to debug all queries. This ticketing system helped to ensure the flow of the class without interruptions. And at the same time, I must give credit to my event coordinators who checked the chat actively and answered questions. So this was how we tried to maintain engagement throughout our workshop. Now I'd like to move on to the competition. So I was an event coordinator for the competition, which we named the Win Petition. This was a 3-day workshop which we planned, and we had icebreakers on the first day. We had workshops in between, and we got them to submit an idea and a prototype by the end of the competition. The majority of the third day was time for them to work on the idea with the team, and we had some games and trivia in between. The trivia was questions prepared by workshop speakers to reinforce their knowledge. We had some booklets to help them along the way. Again, I'll drop the link at the end of this talk, as well as we had a consultation system to guide students along the way. Right now, I'd like to share some of the works by some of the teams. We had 10 teams, which came up with various ideas and prototypes. Some of them used Python, while some of them didn't. This was from team 2, I believe, and team 2 came up with a game. They came out with a Python game. So in this case, they're implementing Python, and this game was a game for them to basically get each of them to continue their story. And yeah, so you can see right here, they're working out a demo. In this case, however, they didn't implement AI into the Python. They just simply wrote a Python script. I will share the links to the submissions later, which you can check out as well. So right here, you can see that they are trying to work on the game. So this was one of the amazing ideas that we had. Now moving on, the second one was more of computer vision, and it was more of CGA. So they came out with idea solution to implement in a Hollywood context. And in this case, they'll be judging the pose of the actors and coming up with a computer animated vision film. In this case, they are also saving their film to a database which they can implement in Hollywood in the future. However, they only came up with an animation showing of the idea and not really of actual code. So this was a really brilliant idea, but more could have been done in the case of getting them in depth with the code. Finally, this is from Team 7.
The same actually is, for example, as you can see, there's no box of being popular on my face. And there's an emotion about it. That emotion depicts essentially what the algorithm is defining by face of spreading it.
Essentially, they're trying to create a face predictor that predicts the emotions, and at the same time, this is to implement for actors. So they're trying to judge the emotion of actors and classify to how successful they are in their acting. And in this case, this team had a whole bunch of code. They had a lot of Python libraries, and the download of their GitHub repository is really big. So good job to this team as well. They managed to implement this live demo, which we tried out, and it worked as well. Now, moving on to the learnings that we had. The very first one is how we can maintain interaction between the groups again. Second one is maintaining fair judging. And the third one is how competitive the students were. A lot of challenges we faced were how we could get the teams to interact, because a lot of them were really quiet and we had to try and get them to get started on the momentum. We hope the icebreakers helped loosen up the atmosphere. And something that surprised us and even surprised me, because our generation of students, and this is something I'm not aware of, is that a lot of us prefer to use other platforms to exchange our ideas. And we are really shy to turn on our cameras or mics directly. In fact, rarely, there were very, very few groups who actually turn on their mics on Zoom. And we had a team of students who simply typed in the chat throughout the competition despite our coaxing. A lot of them collaborated simply through a WhatsApp chat or through a Google Docs document. And this challenge was because this was a virtual competition, a lot of them remained quiet and we couldn't encourage them physically. However, we could, because this is just our vision as our perspective as an organizer, and we could only infer from our site in Zoom. We had some teams which had separate Discord server, which they did likely chat and record their video right there. As you can see this from Team 2 as well, they have a separate Discord server. And in the end, all 10 teams did present amazing pitch videos. So it was fulfilling knowing that they had formed new connections at the end of this competition. And this learning point is how we can embrace this new form of communication and allow them to communicate with each other. Yeah, so moving on to the second learning point, it's fair judging. Because team dynamics were different across the 10 groups, and we didn't want to judge just according to ability, we wanted to open it up to non-computing students and computing students with different code levels, while encouraging them to utilize skills from the competition. We had a lot of tweaks to the rubrics, a lot of late night discussions and changes again and again, and announcements to make sure we conveyed the right message. I think playing our part to ensure that this was a level competition pushes the learning, and this was again another learning point for us. And finally, moving on to competitiveness, I'd like to share simply how the power of a competition was showcased. Starting with quiet teams with constant time pressure, it was a brilliant effort that allowed teams to come up with videos and prototypes. We had very, very competitive teams that appealed for more marks, and this showcases the power of a competition that actually empowers students to go beyond their expectations and come up with something amazing. With that, I would like to move on to the evaluation of the competition. When we evaluate, it's hard to say whether AI literacy has been promoted well. From our trivia questions that were prepared by the workshop speakers, a lot of the MCQ short answer questions were very well answered. The algorithms were well grasped by the students, but code-wise, not a lot of teams managed to implement the codes. From their submissions, only 2 groups implemented AI into Python. A lot of other groups used Python, but they didn't implement the AI aspect of it in. They simply hard-coded an example, while a lot of them used non-code platforms. So this could be an area of improvement for us. Maybe we could have given them more time to interact with the code and possibly come up with a stronger prototype. Considering the profile of these students, the majority of them were non-computing students. I would believe that we managed to spark their interest. However, we would have to go more in depth to push them to actually build up some depth in AI literacy, and more could be done with the use of code or Python. Now with that, I'm coming to the end of my presentation, and I'd like you to remember 5 points from my building blocks journey, how we can maintain the engagement during the workshops, maintain the interactivity between the groups, having fair judging, keeping this competition competitive, as well as keeping room for improvement between to push students to implement code-based solutions. And with that, thank you for listening. This is my student's perspective hosting an event. I thank you all for listening, and yeah, it's been great to learn from all of you. I'm open to any questions. Thank you. Meanwhile, this link here, I'll send the link in the chat now, and this link is to access all the materials to the competition or the workshop or YouTube as well. All of the links are in this one link, so I'll send it to the chat right now. Thank you.
Okay, yeah, thank you. Yeah, so maybe we can take the questions in the chat, as what Mr. Elston has been doing. So we will move on quickly to our lightning talk segment. So first up will be again from Dr. Oka. Right, so he'll be sharing with us an AR tool that SUTD has created. Yeah, please, Dr. Oka. Thanks.
Okay, are you able to hear my voice and see the screen?
Yes.
Right, yeah, so this will just be like short presentations of a project that we actually work together. So Dr. Momen is one of the collaborator here, one of the co-PI also for this project, and also Nacha is actually from the Learning Sciences Lab in SUTD. Right, so I think since the beginning of SUTD, in teaching programming, we have been using robot, and one of the reasons is that there are studies that shows that robotics programming robots actually motivate students because it provides multiple pathways, right? Some are interested in the engineering path, some interested in the visuals, the light, or whatever that is, the mechanics. So we use this as our motivation tools. And then I think since few years ago, we've been looking into different alternatives. We also adapted our course from MIT, and MIT also actually used the AmiGobot in their course for the programming 604, I think, if I'm not wrong. So, but we are looking into we begin to study whether we can replace this physical robot with a virtual robot. So we did a study in 2018. It was published here. And what we found is that there's no learning difference in terms of the learning gain. There's no significant difference between if you use a physical robot as compared if you use just a virtual robot, even as simple as a Python turtle here, right? So we developed a library that allows them to use the same interface, the same command between the physical robot and the Python turtle here. But what we found is that amidst all these things, those with the physical robot, they have higher motivation, they have higher interest in terms of computing, and that's actually what we want. We want people to learn computing. We want them to be motivated in learning computing. So if you see on the bottom right, this of our Likert scale. So the physical robot has quite obvious, more positive attitudes towards computing of them. What we found also interesting is that there are more negative comments when they use the physical robot, right? So actually they have a lot of difficulties. They do not know whether the problem is on the hardware or in the software. So there's a lot of issues. So one of the things that we are trying to do is actually to simplify it, to use a virtual robot instead of a physical robot, right? But we see that there are advantages of a so-called the tangible robot because it motivates the students more. So one project that we are doing is actually to create an augmented reality robot. And so the students have some physical interactions with the markers. If you see on the bottom right there, they put the different cards for the boundary of the robot. They can put the positions of the robot, and then they use the iPad basically to scan these different boundaries, the robot, and also maybe some of the obstacles for them to work on. And then after that, they can just write the code, right? So I just like to show you a video. I hope it runs. If not, then I will share later on the link on the chat. Right, so I'll just stop here. You can look into the video if you go to the website later on. I'll share with you the link. So we created a few tutorials, and from simple like blinking an LED, moving the robot, stop and on obstacles, and so on and so on. And basically, it's quite simple to use because they just have like a text editor. You just click the run button, and then you can see. If you want to debug, you have to use a print statement to debug the robot. There's some API also on the website. Basically, very simple, like to read some sensors, like the floor sensors, like the black and white floor, or maybe like the proximity sensors to detect an obstacles. You can control the lights in the robots, a few lights sensors that you can control. You can control the wheels to move the robot and all these kind of things. So this is a simple code of Python code that we use to, for example, to stop an obstacle. So basically, what they need is simply to initialize the object, and then basically they just like to read the attributes to get the proximity horizontal. And if it is like certain values, then you will stop the loop, or you can keep on moving. And basically, you keep on doing this like for every 0.5 seconds, right? So you can use this like for beginners, like teaching them for sequential. You don't need to use the while loop in the beginning. For example, just like go straight, turn left. And I think this is something many of the pedagogy of the visualizing the code these days, like using Python Turtle or whatever that is. They start with like sequential, and then after they introduce the if else. So there's button on the right here. There's to interact with the physical, because the physical robot actually has some buttons that you can control. So we also have some like API to control these buttons that you can use. So if the left button is being pressed, you can control it to do something like turn on the light or to move the wheels or whatever that is. So it's quite flexible, and the Python is implemented. It supports like Python 2 or 3. It's actually implemented as a JavaScript implementations using a web view in with the AR kit here, because iOS is a bit tricky to include like an interpreter inside it. So we use a Sculpt Python interpreter for this one, and it's actually available free in the App Store. The only thing is that you need iPad with the AR kit that is enabled. So I think mostly the newer generation of iPad can support this. And the markers also you can print it from the website. Yeah. So, and I think if any of you are like interested in like creating learning materials or like lesson plans for this, you can let me know, and then maybe like we can combine resources like for different kind of learning objectives from different kind of stages, secondary, JC, or even university. So in the university, actually, we use it to teach object-oriented state machines, because we actually create a state machine class, we inherit it, and then we use the state machine to follow the boundary. Yeah, so it can be as complicated as that, but it can also be as simple as just like moving the robot around. Okay, so I hope I did not take too much time. I just want to share about this. I'll share the link to the website on the chat. Thank you.
Yeah, thanks, Dr. Oka. Right, so our next lightning talk, actually we have a new one, which was in the schedule, right? Because it just came in during this afternoon, right? But we are actually happy to have another female speaker, but she has actually sent in a video. So maybe let's catch the video first and get her to speak a little bit, right?
My name is Juliana. I'm the founder of LCCL Coding Academy, where I also teach Python. In this session, I'd like to share with you how we transit our students from Scratch to Python. Here is our learning roadmap. In particular for kids and teens, they would spend some time here in coding fundamentals before they progress through the curriculum and eventually reaching Python. And so in order to ask and answer this question, we actually did not start with this question. We instead start with two other questions. The first question is, what are the eventual goals of our curriculum? And while there are different types of goals for the different programs in our curriculum, there is an overarching set of goals that we want students to achieve, which are these: build computational thinking ability, to apply that ability, and then to harness computing technology and code. The second question that we ask is this: how do we take away the obstacles to learning so that students can reach these goals? And the answer that we came up with is by making it relevant, fun, visual, easy to understand, and suitably challenging for those different age groups. I'll be sharing an example of how we do that. And what you will see in that example is how we set up the stepping stones here in coding fundamentals so that when students reach Python, the learning curve is not so steep. This is how the project looks like in Scratch.
$6,230 divided by 70 equals? Oops. 6,230 divided by 70 equals 89. 54 plus 19 equals? Genius. You've got 1 out of 2 correct. Thanks for playing.
The learning process looks like this for the students. We first decompose the project with them, and as they code, they will either learn new concepts or reinforce concepts they have learned in the past. Here is how a progress may look like. Hard code one question, hard code multiple questions, which we then realize we can generalize into one random question, which we then repeat, and then adding in some additional controls and data capture. At this point, for kids level, they are about done. For teens and adults, we would challenge them to come up with random questions in addition, subtraction, multiplication, and division. So after some time of coding, a discussion with an adult learner may look something like this. Abstract out the solution, think of a structure for randomizing, implement that structure, and then eventual code. So I hope in this example, you see how we use one project to impart several concepts. It is the same with Python, but the difference is that once they have a good fundamental here, when they get to Python, the transition is much easier. Here's an example of a transition in Python. Start again very easy with sequencing. Here is one of the next progressions where they learn about loops in Python, as well as pattern recognition. And then when they learn about functions in Python. And the others like input variables and etc. Challenges and lessons we learned. The first challenge we have is the resistance and misperception of Scratch, coming from some people who misunderstood Scratch as a very kiddish platform and had a misperception that once they have learned maybe about 12 hours of Scratch, that they have known a lot of coding enough to move on to other things like Python, Java, etc. Number two is that age is just a guideline. We have had students who are 9 to 20 something who've been learning Python with us, and we find that they progress at different pace depending on how good the fundamentals they have had in the past. We have also learned to build these 3 things early on in their learning journey, which is to build debugging ability, computational thinking, having good code practice, and being able to solve problems independently. Build it early so that they have a habit of doing so in the future. 6 is that we got to pace the fun with the rigor that we let them undergo when we build these 3 things. Thank you for listening. I hope that the session has been useful for you, and I'll be happy to stay in touch. Thank you.
Yeah. Yeah. So yeah, thanks, Miss Hung. Right. If there's any question for her, please also do it in. Sorry. Yeah. So if there are any questions for Miss Hung, please also answer in the chat. Right. We have probably one last lightning talk, right, and that is from Mr. Aaron Ho from Dunman High School. It's a slightly longer talk and it's recorded. So we'll paste the link in the chat to the slides. Some parts may be a bit too fast, but you can look at the site for some of the details.
upskill skills-based formative assessment.
I'm sorry. Yeah.
So let's start with my students' presentation, what they have been doing with the outcome of our paper's investigation. It's an app platform called CityQuest to upskill skills-based formative assessment.
Computational thinking is not something that's analogous to the skills that we hear on a daily basis. It's a skill that's transferable between many different disciplines, ranging from STEM subjects to social sciences and the language arts. It allows students to break down complex problems into smaller ones that they can confidently handle and conquer. Let's start off with some features of CityQuest. Firstly, students have the ability to track and tag certain parts of their answers. Conversations with teachers via the platform's integrated messaging feature can also happen. This ensures that students understand the process and are cognizant of the work that they are submitting. By promoting and facilitating the communication between teachers and students will know whenever they require any form of assistance, and the teacher will always be there to help them. Next, students can also quickly identify learning gaps and know how to improve, as the platform suggests different ways to get to the next academic band. This is done through analyzing which component of the computational thinking that they're weak in combination with some pre-formulated assessment rubrics from the teachers. Next, CityQuest also detects and offers supplementary gamified tasks to students who are stuck on questions or who may want to hone on their skills further. The students are able to earn City points through playing these games. We have a prototype right here to show you. So let me first load the game and log in. They will do for each of the computational thinking components. After the game is ended, the students will be able to see how much they scored for each of the computational thinking components. The score will then be recorded in either a CSV file or on the website. Finally, all of this will come to a waste if the students are not motivated to learn. To overcome this, we have frequent displays of a leaderboard showing the top-ranked classmates with the highest CT points, as well as the rewards they can redeem for each achievement tier they reach.
Okay, so Matt, you've been given a chance to try a prototype. How do you find it?
I think it's a pretty good idea. Yeah, cutting the task up and linking those different portions with the different concepts is a pretty good idea, because you're not just digesting one whole bunch. It's sort of smaller bites, so it's easier for you to process. Another thing that I found was really attractive for me, so to speak, was that I could do the exercises repeatedly at any time as well. And that's a good thing, because you compare it to, say, Kahoot. Kahoot's a good thing. Everybody has fun, a lot of salt, but ultimately that's a one-time thing. And once the Kahoot's over and the teacher leaves the classroom, that's that. But this thing, I find being able to do it whenever I want and as many times as I want, that really helps reinforce the learning, and that reinforcement is pretty important, especially when you're expected to do it under time conditions like, hey, an exam. Yeah, alright, thank you. Hi, good morning, Miss Ling. I've tried the prototype of the app before this. How does computational thinking apply to your subject? Because it counts using the field where we normally apply computational thinking in. Well, computational thinking, I think, can be applied in a lot of things. So, for example, in recognizing how your questions can be interpreted, because this is a common weakness among many students, where they find it very hard to apply what they learn into answering questions. So, if, for example, if we can use computational thinking in terms of helping students to recognize the patterns, keywords in the questions, and then it will allow them to be able to plan their answers better. So it's very essential in helping them to develop the skill of interpreting questions and knowing what content they can use to answer the questions properly. Okay, thank you for joining us for the interview.
So the app is not available for download yet, as we're still piloting, but drop me an email if you're keen to try it out or if you just want to chat. The presentation app design you saw earlier was by my grade 12 computing students who chose to build the CityQuest app as part of a bigger D app, which is an upcoming app from the school with calendar, task organization features connected through APIs. Really proud of them. So to read more about CityQuest in our paper, and these are just basically some of the key points here. Ultimately, what we grade is what we assess and will become what our students will learn. So by explicitly grading the thinking behind their answers, we help our students to stop chasing the correct answers just for the marks, but focus the students on the thinking and the skill behind it. So in our paper, what led to CityQuest is that we compared two possible types of in-house CT assessment adaptations that we thought that we could do. And we found that ECD assessment, although more difficult to implement, was still the way to go. And we proceeded on to develop the CityQuest app platform, which mitigates the difficulties while being equipped with an improved version of ECD assessment, some of which you saw earlier. You might want to check out these resources if you're keen to start on ECD. So the results part of our paper shows insignificant correlation between quiz-based and ECD assessments for the two projects that we use for the investigation. Students use the infographic creator PictoChat and the app builder Thunkable to train and get tested on CT skills. Now here's the key issue. How do I know that we are not hot housing our students? I mean, increasingly, we find more of these students becoming experts at the CT tests and training that are available out there today, but later unable to transfer textbook-based CT to new real-world CT situations. That's one of the biggest challenges that CTQuest aim to solve. We want to see the spark in students to ask the question, hey, why not let's automate this task computationally? Now, don't get me wrong, it's not that the CT assessment methods out there are bad. It depends on what your definition of CT really aims to achieve. Right? For us, it's a project-based curriculum covering AI, microbit, and even UI UX design. CTQuest needs a reference point to grade, so constructing an in-house customized rubric to measure CT skills was our first task, a task which many might find to be the toughest step. So studying these methods here are quite helpful because of the relationship between intelligence and CT. As a result, we added these two skills to our assessment, and also as UI UX because we're inspired by research such as all these. Examples of analyzing interviews and artifacts from students such as this, and interview-like transcripts like this help the design of our levels for our rubrics, and also gives us examples of what to look out for in the CT evidence that we collect from the students, and also help us to design scenarios to put them in, which are also supported by tips such as this as well. And of course, studying other rubrics also help us to inform and come up with a master CT rubric and a customized rubric for each project we were to assess. We study past students' work and establish base level descriptors, each defining how much skill was involved for each component of CT. From this, we develop project-specific questions you see here on the right columns, which we then use to further design scenarios to quiz the students in the case of quiz-based assessments, or in the case of ECD assessment, we design questions to stimulate CT responses from the students when they submit their project evidence to us. This is the rubrics for the CTQuest game prototype that you saw just now. The students predetermines for each line or segment of code the corresponding kind of CT skill and time needed to code it correctly. After taking in the time factor and CT weightage, the final score then contributes to adding CT points for the user's CT account, the user being the student. For example, John did the game faster but got more lines incorrect or not so accurate, while Mary was slower but got more lines correct. So we do the same of rubrics for non-programming topics such as interface design, UI, UX, and it's basically extensive documentation, collecting everything possible, standardizing, analyzing, and before CTQuest, this was a grading and scoring nightmare. It's not possible to continue with this given timetable and curriculum restrictions, along with other factors such as teacher motivation and readiness. And that's where CTQuest mitigates and facilitates. Some key takeaways you might have from observing what we did might be to always test your test to ensure accuracy and validity, and also to check method suitability before adapting. The bottom line is to aim for real-world assessments that measure CT explicitly, formatively, frequently, and in real-world context. Thank you for your attention, and please email us comments or questions. Well, hope to hear from you.
Okay. Hi. Okay. Yeah. That's we have finished all the lightning talks, but now will be the lightning talks. Like what Dr. Liew said at the start. PyCon is really about the community, the people. So currently, these are the people who have signed up. So if you are here, like some of you might have left, but doesn't matter if you are here. Maybe you can just say hello and introduce yourself and say something about how you have used Python. Like so, first up, we have Mr. Keith Anderson. Like, are you around? Like, oh, okay. So anyway, he is he's two computing teacher from ACJC. Right. Yeah. So next we have Mr. Eugene Lim. He's actually a teacher of Mr. Elston, and I think he enough. Miss Patricia Lai is also another computing teacher from Bukit View, and Miss Wong is from Chongqing High School, another O-level HOD computing in charge of the computing and I think CPA. Yeah, I think Mr. Chia is here. Hi. Mr. Chia.
Hi, hello.
Yes, hi.
Hey, hi. I think this conference allows me to keep up with what's going on, so I'm always looking forward to this. Thank you.
Yeah, thanks very much. Okay, next, Mr. Christopher Singh. You were here some time ago. If you are here, can you speak up? If not, we move on to Mr. Aaron Ho. Are you still around, Boss Ho? Yeah, okay, never mind. Next, of course, Dr. Chen. Dr. Chen, just now at the start had some issue with the mic. Are you able to talk? If not, you can always use the chat. Yeah, yeah, maybe it's still having issue with the mic. Right. So yeah. So let's move on. Then next we have Miss Liew. I think Miss Liew just left a little moment ago. Next we have Mr. Suya. Yeah, Mr. Suya is actually a ex Jurong West Secondary School computing teacher, and he hopes actually to join back to service. Mr. Suya, are you still here? Okay, no, doesn't matter. Let's move on. Oh, Miss Juliana was the one who gave the 5-minute lightning talk. If you are still around, would you like to say something? If not, we can still move on. Mr. Melvin Tang, I think he's not here. Boss Chin from MOE CBDD. Not too sure. Let me check. Oh, yes. 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 Can you say something about yourself? Yeah, the A-level computing boss, right?
No, I'm never boss. Yeah, I just work.
Okay, he's looking a lot for A-level computing and more. Yes, Boss Wong is here. Was here. I think he said he's on the move. I mean, if you are still around, then you can let us know.
I'm
Oh yeah,
here.
you're still here. Very good. Yes, please say something.
Hello everyone. This is my second PyCon, and I've benefited so much from the first one. I've learned so much in 1 year because of PyCon. I've started my journey on learning about AI and data science. Last year, I think Jackie was presenting about up level. So I've actually I really appreciate his efforts in sharing his knowledge about data science and AI with his students. I've also benefited from Juliana's teaching, and since then I've entered the Shopee Code League and gone on a few boot camps just to learn about this exciting new area lah. What is my purpose behind this is basically just to cascade this down to my students at the ALP and computing level. Yeah, so that's my journey so far. Thanks for listening.
Yeah, thanks very much, Boss Wong. So next we have we have actually a few people from NIE, but some were not able to come. Dr. Yetter and Dr. Norman. Okay. Then next we have I don't wonder whether Dr. Peter Xiao is still around. Oh yes, yes. Dr. Xiao, would you like to say something? And can unmute yourself if you are still here.
Hi, hello, hi. Sorry, I was in and out from different meetings. Yeah, but good to see familiar names, and thank you for the invitation to attend. Yeah, thank you.
Thanks very much. Okay, next, Mr. Tan Jing Long. Yes, young chap that I met recently. Yes.
Hello, I am a fresh blood. Just joined teaching now at NIE. Previously, I did some. I'm a physics and maths teacher, so undergrad training was in physics. Then afterwards, I want to do some computational science AI things. So I got very drawn to this computing and the computing conference, and it's my first time here, and really learning a lot from all of you, from both teachers, university lecturers, the private side, and the students as well. So good to see everyone.
Yeah. Okay. Thank you. Yes. Boss Chin, this will be the one who wanted to become a computing teacher. Yes. Yeah. So I think Boss Chris Hang was here at the start. Yeah. So of course we have our ultimate supreme boss, Prof. Leong. Yes. Prof. Leong. Yes. Would you like to say something? Oh. Yes, he's still around.
Mute myself. Sorry, let me unmute myself. Okay, I think the super boss here is Mr. Gee, actually. Okay, and also, I think the other one who has been regularly here is Oka. I think he deserves some kind of a long service award, So Mr. Gee, put a challenge to you. You must give him a long service award for his great contribution, consistent, Okay? And I'm very happy to see. Actually, I shouldn't be here. I don't code in Python, so I'm the guy who is trying to sneak in, pretending to be doing some work. But great to see all of you. I'm very happy to see the community come alive. And I think I recall that about 4 years ago, when I ran my competition, the Code Extreme app, Professor Peter Xiao was the one who taught machine learning for kids. This was at the time when nobody was talking about machine learning yet, and we were teaching machine learning to primary school students. And I still recall, Professor Peter Xiao was the one who became the lead instructor. We found the tool that integrated, some AI capabilities from IBM. But I actually have something, that as I saw all the talks that interesting talks that came about. I have something which is a little bit too long, so I have typed it in case I cannot pronounce it very well here. One of the things that always stuck in my mind is this. And I think Oka mentioned it today. When we teach programming, at the same time there is problem solving, and sometimes we mix up the two things. And when the student gets stuck, they do not know. I remember very often, students get stuck, and I often ask them, where is your difficulty? Is it problem solving, or is it syntax and semantics of the program? And they cannot distinguish. And so one of the questions that I have at the back of mind is, harder question to think about. How do we incorporate the spirit of looking for as many solutions as you can for a particular problem? Not just one. Do not be happy with one, but find as many solutions as you can. And if you develop that habit, then for Oka, then the toolkit that you're talking about is being built. And not only they have one tool, they have many, many tools, to think about. So I want to leave everyone with this question, which I will type into there. I've already typed in. So I'm going to just press return, and you can take a look at this. But very nice event. Thank you very much.
Thanks very much, Boss Yong. Boss Yong was my lecturer last when I was in Tang was Department of Computing. Yes.
Yeah, he didn't say that he's Ching Chu Yi Lan, now he's way better than me now.
No. So next, I think, do we still have Mr. Shen Hong? Are you still around from Republic Poly?
Yes, I am.
Yes, please.
Yeah, Boss Young is also my lecturer. So I used to work on Python web only. So last time I used to be a Django contributor, but now I've been taking up several projects in the data science and machine learning area. So building stuff for on a voluntary basis for the time being. As I mentioned, I actually taught, just gave an introduction lesson to the Republic Poly students. That's the closest I've done. I've came to teaching Python in school, in any formal setting. So very happy to learn more. I'm mainly a Java lecturer, so very happy to learn more and listening to a lot more. So by the way, I've came for PyCon 7-8 times already, but never education. So very happy to join you.
Welcome. Yes, please join us next year. Yes.
Definitely.
Okay, so Boss Chan gave a talk. Mr. Tamil is supposed to be here. He's actually one of the regular speakers who also contributed in PyCon Education Summit, and he actually wrote programming textbooks for Bangladesh children, right? Most of them in Bangla, right? Yeah. So next, we have boss Mr. Robin Pang. Yes. Would you like to say something, Boss Pang?
Hi, I'm Robin from SST. I like the sharing today. There's a lot of things for me to take away. I like the part. Let's see. I took down some notes. I like the recursion visualization. I think I would implement it for my students. I like the idea where I think Prof. Liang was saying about not using the IDE to compile the whole idea of punch card. So I am thinking about implementing a pen-only algorithm competition for my students, and I will penalize them for every time they compile their codes. The last part was Mr. Oka talks about sub-goal implementation. We do use this in our teaching daily life, but I think it's really good that he mentioned it up again. I'm also open to any other suggestion or collaboration that anybody is interested in. You can always reach me. You can get my email via Mr. Gee as well. Thank you all.
Yeah, thanks. Yeah, sure. After this, we'll share the actual mailing addresses with all the participants. Thanks. Right. So after that, we have, I think, Mr. or Miss Dewi San.
Yeah.
Yes. Are you still with us?
Is she around?
Okay, let me quickly check. I saw her.
Yeah.
Okay, probably no, not now. Yeah, but doesn't matter. We can move on. Mr. Kenny Lu. I think he was here. Not now. Also doesn't matter. Okay, Dr. Norman Lee. Yeah, Dr. Norman is also one of the most regular presenters. Yeah, unfortunately, today we didn't get to hear him, but let's hear for him for this 1990 talk for a while. Yeah.
Hi, I'm Norman. Not presenting anything today, but I'm equally happy to learn from others here. Yeah.
Okay. Yeah. Thanks very much. We have actually a researcher at SUTD. She was here a while ago, and Mr. Vishwan, I don't think he's here today. Mr. Chua Kok Chai, are you still with us? Probably. Okay, probably not. But we have Mr. Richmond. Yes, Mr. Richmond is from Zhonghua.
Yep, that's right.
Yeah.
It's great to be in the midst of big names in the community. For an O-levels teacher like myself, it's great to see where the SSTs and SUTDs are leading the direction for it, and where the A-levels and the further areas, higher institutions are leading as well. So it's always good for us to see where we can gear our kids to end up with, and it's always great to see Prof. Leong and all the others again. Right. Thanks.
Yeah. Cool. Yes. Yes. Mr. Su is together with Mr. Kawing Heng, and he's a trained naval diver, so don't pay. Yeah. Anyway, yeah, we have reached the end, and we will do a quick photo taking. If you don't mind, please on your webcam, and we can try to do a screenshot. Okay, cool. Right, so by the count of three, 1, 2, 3. Okay, one more time. 1, 2, 3. Yeah. Thanks very much. And the last item of the day is, of course, the lucky draw. Yes. So we have, as usual, our annual lucky draw. This time around, the prize is a mystery, right? So we will follow up with that, right? But for now, let's run the script. Right. So we have a lucky script. Okay, this is PyCon, right? So we'll see who is the lucky one, right? Yes. So who is lucky? Any names? If not, it must be me. Right. So are you sure? Of course, I'm sure. Oh, okay. Sorry, I'm not lucky. Right. So let's try again. Oh yes, everyone is lucky. Yes. So everyone will try to get something, and we don't know what is it yet because it's a mystery. But we'll follow up with your suggestion. And yeah, yeah. So anyway, thanks very much for coming. For sacrificing your Tuesday afternoon for the mainstream schools. It's still a holiday. Right. So hopefully we will follow up with the email and with the recorded video as well as the links to most of the slides presentation and resources. And we'll also share everyone's email addresses. Right. So thank you all for coming, and sorry we overran as usual. Right. Yeah. So see you next year, and bye bye. Yeah. Thank you.